Alright guys, welcome to another video, and in the previous video we explored numerical Python. In this video we want to explore pandas. And pandas simply means that when you look at the formula, just like NumPy numerical Python, pandas simply means panel data. Okay, that's just what it is. Let me take all of this out. Just put it as panel data. Into brackets, pandas. Alright, so that's what we have on numerical Python, which we have covered as NumPy. Okay, let's collapse NumPy. Now, what is pandas, or what do we want to do with pandas? Well, it's one of the libraries of Python, and just as we mentioned, or just as it has been emphasized when we're looking at NumPy, is that it is built on top of NumPy. Okay, pandas is built on top of NumPy and is designed for data manipulation and analysis. It introduces two major structure, right? One is the 1D array, and the second one, 1D is a series, and the second one is DataFrame, which is the 2D array. Okay, or table. Majorly we call it table. So a single one, it's the array, and now we can call it table. So why should we learn pandas? How powerful is pandas? What can we do with pandas? It gives us the feel of Excel and SQL table, right? Because it's in rows and columns this time. We can see just like we have a spreadsheet, or just like we have an SQL table. We have labeled axes, right? That means we can access data by the labels. And access data by the labels. For column names, for rows, we can just use the indexes or indices, right? Index of the rows. Okay, you can use it to handle missing data, which is very powerful. Or majorly, let's just use the word data cleaning. Handling data cleaning, it is very fast to clean up data, regardless of the number of data you have, or the amount of data you have, regardless of the volume of data you have. Pandas is very fast for data cleaning. Okay, we have grouping and aggregation, right? Something we're already used to, and there's a spice after grouping and aggregation that you see shortly. So just make sure you stick to the end of the video. It makes you, now if you ever have intimidation, probably you've learned Python before, majorly pandas, and you still feel intimidated, by the end of this video all of those things will be a bygone, right? We also have time series functionality. You can use it for time series data, and it can integrate with NumPy and other libraries that we have. Okay, so a series is just like a single Excel column, right? Single Excel column, while DataFrame is the entire table itself. So let's see what we can do. Let's just create a Pandas series, then we jump into data frames, where we will do much more. Okay, alright, let's just get started. First of all, let's import libraries, and in this case it's just good to have NumPy imported as well. Okay, so import NumPy as np, the alias, and import pandas. This way we'll give it also an alias as pd. This is the general convention. Okay, so let's just execute that. So we'll let that connect. Alright, we're good. Let me create a new cell below. Alright, so now that I've imported pandas and NumPy, we can now create a series. So the starting of the series, And a series, as we already know, is just a single 1D array. But compared to NumPy, this can hold any data type, right? Integer, string, float, object, etc., etc. So it can hold any data type at all. Okay, so let's just create a series. We can call it calories. Okay, let's say someone is tracking his calories, and today is like the third day, and they've been tracking, or just after a week, right? That makes more sense. Let's do after a week. So we want, let's say, day one, and maybe they're just tracking for the morning period. So calories morning, let's say 390. We can also say 650. Let's say they have this spike at this point. They'll say 470. Alright, Monday to Friday. So they're doing a check on a Saturday morning, right? So this is just a simple list. So we have to say my series. Then we can convert that to a series by saying PD. If it was to be an MP array, we go to MP.array, but in this case we do PD.series. And pay attention that series in this case starts with a capital S. Do not make that mistake. It starts with a capital S. Okay, so in here we can pass in calories. Let's say creating a series. Creates a series. Alright, so we have PD.series right there, and then we can print it. I'll say print as usual f string for the double quotes, then series from list. My series. Okay, where my series, and just to check the type, let's say type of my series. Okay, so let's start with these and print. Let's print this first. I'll be using Alt Enter to print so that I can create a new cell for us at the bottom. So Alt Enter. So that created a new code cell for us at the bottom, and you can see that this is what we have. So we have CSIR4. So I think I should do a \n. Alright, so I'll just do a Shift Enter now, so it jumps to the next cell. So you can see series from list. Oh no, not before our semicolon. So \n twice. Alright, let's see how that looks like. Okay, good. So this is what we have, and we don't want this space. We also want a space before the type. No, yeah, just \n. Okay, this is part of this, so put it right after this guy, \n. So run it again. So this is what we have. So it's showing us we have the series, and you can see that it's saying the type. Majorly, let's look at the type. It's saying is a series.series, Pandas series. So this is what we have, and this is what a series is, just a single and you can see that the index or the just as you see here, the row labels are what are the index, right? The row label are index 0, 1, 2, 3, 4. That is what we have in there. So now let's create a series with a custom label. Okay, This one just has the index as the label. So let's create another custom label, series with custom label or labels, right? So when I say labels, then we can say that will be Monday. Okay, I think this should just be a list. Since it should be a list, we'll just use our list method. So Monday, Tuesday, Wednesday, Thursday, Friday. Okay, so now the actual series, which is what we now want to do, we want to create a series that will hold the value. Do not forget that this will be the labels instead of saying things like 0, 1, 2, 3, 4, 5. Right, I decided to change the labels to a text, okay, instead of the default index that we get before. So we'll do a calorie count. So we'll say calories count. Let's just use CNT. Will be pd.series. We can pass in our list here directly. Okay, pd.series, and then we have it. Open a bracket. The first thing is what did we name it? Calories, and then we pass in index. Now do not forget, you can see it says you pass in an array, then you can pass in the index, you can pass in the data type and all of that. So we want to pass in the index, and then we say the index will be labels in this case. Okay, so let's print this out and see what it looks like for us. Index, labels, let's just say axis label. Alright, let's leave that and print this directly. This is a list. Yeah, calories is a list. Let's run that first and see what we get. Oh, okay, I omitted the split, right? Just right there, I omitted the split, so this is not being seen as a list. I just typed and I didn't even remember to put it. So it's saying, oops, this must be calling some kind of value that we can. So let me do splits right there. Alright, you can see now that the error has gone, the red underlined version. If I take it out, so Python is now Colab is able to detect that okay, there's going to be a problem in advance. So and pull it back, and it's going to take this out. So the next thing is that I want to print. I can just copy this and say labeled series or axis series, whatever English that will be. We'll paste that. We want to remove this. We don't want to print the type again. And we want to call this series with custom index. And there's a series with custom index into brackets row labels. Okay, so this will be calorie count, calories count. Okay, and that's what we have. So let's print that out. I think one should be fine just there. Alright, so I want to print this. Don't missing anything, I think we're good. So let's execute it. And yeah, you can now see how it looks like. So series with, oh, I think I need another one. Alright, so series with run that again. Good. So we have series with custom index, which is row label. So we now have Monday, the calorie count, Tuesday, Wednesday, Thursday, Friday. So instead of just having the 0, 1, 2, 3, 4 and all that we have, we now have a better way of viewing it. So let's look at how to access elements. Excuse me. So let's see how to access elements in series. Okay, do a code, and then we'll say accessing or access elements in series. No, in a series. Series is plural, right? So just keep it that way. So we can say, let's say we want to check how many calories was consumed on Monday. So we can say f calories consumed consumed on Monday morning. The calorie consumed on Monday morning. Let's put this word Monday morning. Then we'll put this and then we'll pass in the value. Now we want to access just the Monday calories only. Okay, so we'll put in the variable name first, which is calories count. Auto suggest, okay, calories count. Then open a square bracket, open a quote, then inside there, single quote or double quote, inside there we can now type in the particular one we want to access. So we can say Monday, just like that. So we can say Monday just like that. So if we hit enter, let's just do Control Enter so it stays there. You can see that's been able to grab Monday calorie. So what about we say Friday calories? You can see 470. It has been able to grab the one for Friday. Okay. So let's put that there. So yeah, now we change this to Friday morning. Okay. So what about calorie consumed on the first morning? Right, the very first morning. So as a calories count 0. And download, and you can see it has been able to do what? To grab the calories for us, right? Calories count 0. So using the 0 index is grabbing, it's able to use the index to get it for us. And by the way, this is just a warning. And if you read the warning, it says future warning. So it's a future warning. It says series of data item treating key as positions. It says deprecated. It says in future version, integer keys will be treated as labels consistent with DataFrame behavior, right? So to access value by position, we have to use series but iLock. But we'll still see the iLock and the lock in DataFrame once we get into it. Okay, so it's just a warning. Nothing is wrong. Okay, where are we? Okay, oh yeah. So we have been able to do what? We have been able to see, let me scroll. Okay, we're not scrolling, everything is visible. Yeah, so we have been able to grab a particular value or an element in a series. Okay, so next up now we want to look at DataFrame, and this is where we now start looking at things that look more like spreadsheets. We have rows and columns. We want to work with CSV files. We want to do some advanced manipulations and all of that. So let's just jump into it. Alright, now let's take a look at the DataFrame. I will expand this. Just like we have seen, series is more like a single Excel row column, while DataFrames are more like entire Excel worksheets, right? The Pandas DataFrame is a 2D, two-dimensional data label data structure with columns of potentially different data types. It's like a spreadsheet or a SQL table or dictionary of series objects. Okay, so we'll just jump into creating one without wasting time. So we'll create a data frame right here. We already imported NumPy and Pandas, so we can go ahead and use them. We don't need to import again in another cell. Okay, so we can just say data. So this will be a dictionary first. Okay, so we'll have name, and then we can have it as list, Alice, Bob, Charlie, Darwin, dot split. So this gets us a list. Okay, then we'll have the age of those people. So in this case, you can just maybe make this capital, since we want them as column name, but it's fine as lowercase as well. So what are the ages? We just put in 25, 30, 35, 28. You're probably expecting 40, right? Just break the pattern that way. So city will be New York, London, New York again. Since we're not using abbreviation, so let's type that in full. Of course, in this case, it will split the way I don't want it to split, except we do New York this way. Alright, New York. So we'll just keep it as NY. Okay, keep it as NY. Then we can maybe manipulate and update that later. Dot split. So this is what we have, and we print this first. So let's see what we have. Let's just go to step by step, see what we're doing. So this should be a dictionary. So we run that. Okay, so we can see what we have. It's showing us as a list, proper list. The age is there and everything we need, which is fine. Alright, let's take it out now and convert it to a data frame. So we say df, which is more of a convention, is a variable name, is a convention popularly used in Python when working with pandas. Df is just data frame. Okay, then we say pd dot, the same way we have capital S is the same way we have this to be Pascal case. Okay, so it's data frame. D is capital, F is capital as well. Then we'll pass it in data. Then we can print the data frame. Just say data frame from a dictionary. Then we'll pass it in that way, df. So we can give it a backslash n, just like that. So if we run this, you can see how nice it is looking, right? Data frame. If we print it like this on its own, okay, Sam is running. You can see we're getting a better feel of it, and you can see we have some AI suggestions. You can see convert this to data frame, says to an interactive table, right? Just AI features right there. You can see what it looks like. Why did it print twice? So in that case, we can just do this instead. Take it out from here. Since that looks nicer than this, okay, let's put it manually. So we're printing this and then we're done. Okay, so data frame from dictionary. And you can see we have the name, the age, and the city, just like an Excel spreadsheet. You can see how nice that is looking. Okay, so feel free to explore the interactivity of what we have. We'll just proceed with the next thing. So let's say when we get the first few rows, now we want to see what is inside our data. We can do df dot head. Okay, df dot head. Usually head gets us the first 5 rows of data, and our data is not even up to 5, so you can see it's getting us everything at once. So we can put in a number here. Let's say just the first row of data, df1, and if we run that, so we're getting just the first row of data. If we want to get the first 2, then run it this way, we're getting the first 2 of the data. The same way as we have head, we also have tail. Okay, so let's see how to add a tail. Tail just gets the last few rows, so it depends on the number of rows you want. So we just say df.tail, then we can pass in the last 2. Run that, and you can see it's getting 2 and 3, just like that. Okay, let me close this. Let's add more code cells here just to do a few things. So that is it. And I want to find out about our data. Well, let's see if I want to find out about our data. So then there's the df.info. Open and close the brackets. Run this. And you can see this gives us a quick summary about our data. It's telling us total columns 1, 2, 3, 3 columns. And you can see them. For the columns, we're seeing the name. It's showing us the total number of null and saying for non-null, and it's showing us the data type of the values in individual columns. Okay, alright, so that's how to do a quick check of what we want, right? Just to find out about our data or get to know our data. So what if we want to get the numerical statistics, right? The descriptive statistic for our numerical columns. We can do that using df.describe. df.describe. Then we execute that, and let's see what we get. If we print it, we get all this funny look. Okay, so we get all this funny look. And you can see counts. It picks the numerical column by itself, right? So it's just saying that this is the age column. We have 4 values in there. This is the mean, this is the standard deviation, the minimum, 25th percentile, 50 percentile, 75 percentile. Okay, so that's Q1, Q2, Q3, things like that. And this is the maximum value in there. So that means the highest age or the oldest person is 35, right? And if we look back at our original data, that is correct, and that's Charlie. Okay, so that is Charlie. Alright, now let's see how to access column. Okay, access columns. We have 2 methods. The first method is what we'll be using, but the second method is just so you know it. Okay, so we can say df, the square bracket, then we'll pass in the column we want to get. So if it's name, if it's age, if it's city, for example, we're passing city that way. Then if we run that, you can see we're grabbing the city. The same thing we can do the dot method of it. So dot city, but it's not, why this is not a good practice is we use other methods using the dot notation, so it's not advisable to use this to grab the column. Let me comment this out, the columns. Okay, so if we run this now, you can see we're getting exactly the same thing. Okay, we're getting exactly the same thing. So what about we want to access multiple values? You can say df accessing multiple values. So in this case, we want to do print. Oh, okay, I'm not printing so far. We can just do df. Then we pass in, as usual, a list of lists. In cases where we're using numpy, we pass things as tuple. So in this case, we pass lists. Okay. So we then list out what we want to get. We want to get the name. We want to get the city. Let's say we just want to get the name and the city. We want to see the names of people and where they live. So we run this. It grabs just those two for us, right? Just grabs those two for us. So with this, of course, there's still more to do with it, and yes, they're just in right here. So for now, we have seen this is more like an introduction to DataFrame. In the reality of it, we'll be working with an actual data, not creating all of this from scratch. But sometimes when we're trying to grab data online, maybe web scraping or different sources and all of that, we might need to convert this data in this way. If it's just a small use case data, but most times we can just connect this to the database, and we save the data into the database, and then we can work with it. So I'll just take out these columns, so take them out, take out, collapse this, and then we'll jump into some hands-on for pandas. So close up. Now let's see what we have here. So now with pandas, we can easily load file. Okay, can easily load file, work with a CSV file you have existing, work with a JSON file, an Excel file, whatever it is. Pandas makes it easy to work with. Okay, so in this case, how do we connect to data? Right? How do we connect to data? Let me just put this here. Okay, let's just see connecting or reading files. Let's use the word reading. That's the way, reading files. Okay, so we have the .csv. Now let's just type pd dot, then we do a read. Then now immediately we put a read, even before the underscore, you can see it can read a clipboard, CSV, Excel, HTML, JSON, and so on. You can see you have everything right there. You have them just right there. So let's create one data type for ourselves. One data frame, I mean, I want to create a CSV file, so we can go to dummy CSV. So we can see the name, the age, and salary. Okay, write the name, age, salary, and there we can put a \n. So this will be John, comma 30, CSV file, comma separated, right? That's what we're doing. Alright, let's do 50,000. So we want the \n again. Jane, 24. Let's say 45k. We want the \n again. Let's do Mike. J. Let's do Jake. Okay, so Jake, 35, 60k. Alright. K now. Okay, Kimberly, 28, and let's say 5200. 52k. and this is what we have. Okay, using the backslash n, this is meant to be another row, another row, another row. We want to create, because it's going to be a dummy data, so we're trying to create this ourselves. I will be using the file opening method in Python. Okay, file handling method, I mean the file handling method in Python. So we'll do a with, then we'll say open, then we'll just say this dummy data .csv. So w is for write, so we'll say w, then we'll say as f. Now in here we'll just do f the write on the dummy data we created, the dummy CSV. Okay, so we want to write this as a file, and just right after there we can okay, just leave it on the same cell, so we can create open, then we can say df CSV, then we can read it normally like a CSV file, so we'll say pd.read underscore CSV, then open it and then pass in the dummy data that we have here. Control C, oh, dumb, that's dummy. So copy this and paste it right there. Okay, so down here we can now print d underscore CSV. Okay, so let's go through this. At this point, of course, this will be backslash n is going to a new line, so basically creating a CSV file. We already ensure that we have comma all through CSV. Okay, that's correct. So we already ensure that we are using commas so that we get a comma separated value file, and then we're using the backslash n. We'll just want to create a small data that we can work with. I'll say with this data, this file does not exist before, but it will upon running this code. Okay, and passing this to read it as a CSV file, or saying pd.read. Now read this file that we're creating at this point as a CSV file. So let me say creating file. They should be creating a CSV file. Then down here, this will be reading file, reading the CSV file. Alright. So let's execute this, and it's executed. Let's execute this, and you can see that we already have the file just like that. Okay, so let me take this out. Okay, so let's run this again so you can see how well it is now showing. We have been able to create a file like this, right? We have been able to create a CSV file just like this. Now, next thing we want to do is let's inspect our data. Let's know our data. I want to find out what is in our data, right? And since we already covered all of this, let me take this out. We just what is our variable name? df underscore CSV. Okay, let me comment all of this. Okay, print. Then we'll do do the same thing for this, df underscore csv. Okay, that's dot add dots. That's how I get to where the dot wasn't there. So run that again. So we get the head, the first 5 can pass in was 2. We know how the tail works, we know how the info, we have not seen the info before. So let's do the info, df underscore csv dot info. If we execute that, you can see what we have, just basically the details of the data, and we also have the memory usage as well. So we have done describe. Let's check shape out and columns. Okay, so these are useful options right here for us. dsc underscore csv, df underscore csv, and df underscore csv dot columns. Okay, so it has to be plural, columns. So let's run the shape first. Let's comment this out now. Run the shape. This telling that is what? 4 rows, 3 columns. And that's correct, right? 4 rows, 3 columns. That's the shape of our data. And if we run this, which is the last one, you can see the column names just like that. Okay. So let's jump into some important things about our data. Let's start with selecting the data. Right? We've seen the basic things that we want to see here. So we can now start seeing maybe selecting the data, sorting, filtering, and the rest. Then we look at how to handle missing values. Let's expand this, and so when we select data using the lock and the iLock, okay. So the iLock is using the index, but the lock is just using the name. Okay. As you probably have guessed, lock is simply location. Okay, so let's look at what we have in our data. So up here we can just print the df underscore csv, so that we can grab what we have in there and work with that particular one. Okay, let's just network. We'll just wait for it. So this is what we have. So that's printed. So let's say we want to grab the 3rd row. So we can say df underscore csv. Then we'll say dot lock. And then in this case, we'll pass in the row index. Okay. We just look at different methods of selecting data or of grabbing data. And then we'll move on gradually. Network is really being a problem right now. And you can see what it did for us. So since it's just a row, so you grab this, it's showing it as a column. So you can see df the lock to let's just say grabs row 2, right? Row 3 index number 2. Alright, row 3 index number 2. So we can pass in this to grab the data. So what if we want to grab more than one? So we can say df underscore csv dot location, and this time we want to grab let's say more than one row. So we can say 0 to 0 to 2, so that it will pick the first and second row for us. So 0, 1, 2, so 0, 1, 2, 0, 1, and 2. So you can see that we have been able to grab 3 rows. Right? We have been able to grab, if you look at it, John, Jane, and Jake. John, Jane, and Jake. So I've been able to grab that successfully, and it's returning all the columns, right? What if we don't want all the columns? What if we don't want all the columns? So if we don't want all the columns, we can just add a comma. If you remember when we were doing this earlier, Then we can pass in a list. Sorry. Then we can pass in. We can just say let's use the index first. So that will be 0, 1. Now this is raising a type error. So it's telling us cannot slice indexing on integer with this type of indexer, with this indexer 0 of type int. Okay, so what does that mean? That means we pass in the name for the column axis because they are labeled, they are named. Okay, the row can use the index axis while the columns use the name. So what do we have? Name, age, capital. Okay, capital. And then you can see I'll be able to grab the name. So let's see if we run this. We grab the name. If we put in city, now you can see the problem is saying, oh, do we have city? Let's go back. We don't have city. So come here, we say salary. And you can see we can grab any of the columns with a certain number of rows. Okay, so if we want to grab just the say the salary, we just put age colon salary, just like that. Okay, however, we can also do something like this: df underscore csv dot lock. Okay, and then we'll pass in a square bracket. So we'll pass in this. Then we'll say we'll say 0, comma 2. Then we'll come out of the bracket, put another comma, open an underscore bracket, and then we'll grab the name. We'll grab the salary. So if we execute this, now it's grabbing specific rows and specific columns. Okay, remember we are not using range in this case. We're just grabbing specific rows and columns. So grabbing specific rows and columns. So this one is grabbing same thing as well, right? Same thing as well. But this is more of a range, right? It's just more of general range. So from this to this, but this one is it can move, it can grab between the lines, right? So we can skip name, we can skip age and pick name and salary. But if we use the column range, it picks everything. Okay. We can also do a conditional grabbing. We can do a conditional grabbing, but I think we are filtering data here. Okay, so we'll do that when we get there. So we can do a conditional grabbing. This is the lock method. So just say lock method. So now let's look at the lock method. So when we look at the lock method, and this one uses position based, right? It uses position based. So we can say df underscore csv dot ilock position, which in this case simply means index. Okay, so ilock, and then we'll pick 1, for example. If we execute, you can see it's grabbing what? Jane. If we go back to our data, Jane, don't forget that it's using the index, so it's grabbing this particular person. Okay, we can grab, let's say, the first row and the second row. So df underscore csv dot iloc. Then we'll do this now so that we can have clarity. We will use 0 to 2. Okay, I will also use 0 to 2. So just say 0 colon 2. Now, what is that grabbing for us? 0 and 1. However, when we executed this, if you remember, this was giving us the first 3. Why? Because this is location. So this is acting. Now these numbers you're seeing here are, even though they are by default, they look as an index, they are a direct access. But when we use indexing location, let me simplify that. When using location does not use index. So we're seeing this as an address. So grab 0, grab 1, grab 2. Okay. But when we are using index, by default, the last value is exclusive, and that is why it did not pick Jake in this case. So that clarity is important, so that you just get it that way. So how else can we grab data? We can also grab certain columns. So if we say, for example, 0 to 2. Now when we try that at this stop using iloc, when we try that using loc, it's running into an error. Why? Because it's location, it doesn't use index. But now we are using index, so we're saying grab 0 and grab 2. Of course, 2 is not inclusive, so it will only grab the first and second column. Okay, the first and don't forget, it is always row first, then column. Row first, then column. Row first, then column. Okay. Right. What other way can we grab? Let's say we want to grab all the rows and the last 2 columns. df underscore csv dot iloc, and then we'll put in this, we'll say all rows and the last 2 columns. So for us to do that, we just say column. That means grab all rows. We're not specifying starting point and ending point. Okay. So let me put that. Let me add some space. All right. So you can see that clearly. So from the beginning to the end. After that, we want to pass in what we want to grab. So since it's the last 2 rows, 0, 1, and 2. Just have 2. So we can put what? 1 and then column, since we're grabbing everything. So if we run this now, this is now grabbing the last 2 columns, but all the rows. Okay, all the rows, just like that. So yes, these are some useful ways of grabbing rows and columns. Okay, so some useful ways of grabbing rows and columns. Mind you, this is location method, iloc method. Let me put them together. And we also have the native way we used earlier in the Pandas series. That's passing the name inside the data directly, inside the square bracket directly. Right, so you can say using column names. Alright, that's the way it is. Column names, not column name. Okay, column names. Yeah, column names. Okay, so we can grab, can just say df underscore csv, and then we'll pass in. You can see it's giving us age. If you want to grab only the age, we run that. We're grabbing only the age. If we want to grab, let's say the name, we'll put in the name, just like that. Can grab more than one salary, just like that. We pass in a list of lists to grab in more than one column. So you see, we're grabbing the name and the salary, something like what we did here. But here we are also specifying certain rows that we want to grab. Okay, so we can do that as much as we want. Okay, so the first one was age. So let's take it back to age, and I'll remove the unnecessary double square bracket. All right, so we can also grab data this way. All right, so this is just some few ways, or majorly the key ways of grabbing data, using the lock, which is location. If you want to grab certain rows, you use the label, because do not forget this is the label 0 1 or 0 1 2, right? So 2 as a location, then 0 3, 2 as a label. Okay, 2 as a label. So you can use the location method, the iLock method, and also the column name G, using the column name method. Alright, so let's look at how to sort data. Can I collapse this? Is there a way that I make it possible? Okay, I didn't. Alright, let's just look at how to sort our data. Come in here and say, let's just say we want to sort by age, since we have the age. So sorted, or age sorted. Alright, so age sorted. Then we can see df underscore csv dot sort underscore values. You can see it says sort values, and then do that, or open it, and then we pass in a by. You can see how straightforward it is, right? We say by age, that means we want to sort by age, and then we can pass in the order ascending. Then we can say true, that's from lowest to highest, just like that. And then if we print age sorted, then age sorted df, then I can remember it's a data frame, not just a variable, a random variable. Okay, so age sorted df, and then we execute that. Then we can see that it has now sorted them by the age. So it's as simple as that. We can sort by the age, sort by salary, and whatever it is you want to sort by. Okay, what if you want to sort in descending order? It's simple. We just say sort ascending is false. Okay, what we have ascending right here, we just say ascending is false. So let's just sort by name, so that you can see that it doesn't just sort using numerical data. Okay, so just copy this, and then we'll say name sorted this time, name sorted, and then this time we'll sort in descending order, name sorted, and then we'll say we're sorting by the name, and then we'll say ascending is false. That's all. So in this case, we'll be saying Kimberly first. And you can see we're having Kimberly, then John, then Jake, then Jane, then Jake, just like that. So you can sort on any column at all. You can sort on any column at all. So the next thing for us to look at is filtering. How can we filter our data? Quickly, you can just pause the video, try to sort by salary. And like I said, it's very easy to do. So let's say we want to find people. Let's say we want to find people older than, because we don't know if they're customers, they're students, whatever it is. Or let's say employees. Let's give them a name, employees. We want to find employees older than 25. So that will be picking. Okay, we want it to pick 2. So we can say older than 30 or 30 and above. Let's use the word 30 and above. So grab employees from 30 and above. So we can either save that in a variable, or we can just try to print that directly without really saving it. So in this case, we're not saving it. If it's something we want to reuse, it's good that we save it, but in this case we just want to demonstrate it. So I'll say df, let me take out the print so that I can see it clearly. Filtering data, df underscore csv, we'll open a square bracket and then we'll pass in our condition. So we'll say df underscore csv underscore csv. Now what do we want to do? This is the condition. Do not forget that. Now don't be confused while we're using this way. This will return boolean, only this will return boolean. So the boolean will now pass into the particular value. And take a quick look again on how we did it earlier. Okay, I think that was numpy. Yeah, I'm thinking numpy. Yep. So here we just say df and then we'll specify the column we want to filter on, just like that, age. Then we'll say age greater than or greater or equal to 30. So let's see what that prints for us. And then you can see we're getting just 2 people like that. So what else can we filter? We can have multiple conditions. Okay. Employees, older employees from 30 and above. Now we want to use multiple condition. We want to use the age and the salary. So I want to say df underscore csv, and then we'll say in this case df again underscore csv square bracket, age is greater than 25 and df in the square bracket salary. So salary is let's just say salary is greater than, let's look at all the values, 45k, 50k. So let's say salary is greater than 50k. Greater than 50, 1, 2, 3. Just for readability, right? Just for readability. So we want to see people, say combining condition, chaining conditions using and. Alright. Now do not forget that if we run this, we'll get a shout. Now what is the shout? It's just saying there's an issue. Let me see. df underscore salary. So it's saying key error salary. Let's check. We have salary right here. So what are we supposed to do? Conditions are wrapped in parentheses. So there are 2 different conditions, so wrap them in parentheses just like that. Okay, so we run this again. Okay, now we're still getting the key error of salary. My bad. Now I can't even show you that we had a different error earlier. So let me remove the parentheses first. Okay, the parentheses are gone. So let me correct this. CSV. Alright. So now we are no longer having the value error or the key error saying salary does not exist. This time we're having what? The ambiguity we had earlier. And that's because we didn't wrap each condition in a parenthesis. So wrap it, condition 1 parenthesis, condition 2 parenthesis as well. Alright, so you can see we're only getting 2 people. Why are we getting 2? This guy is older than 25, but is not any more than, because we said above. So 5,000, 50,001 is above, but 50,000 is not above 50,000. Okay, so that's why we're only getting these 2 people back in return. Alright, let's say we want to use the AND condition. I want to get people either named this just see you want to grab the name of the people or by the age. So finally you can see, again, I'll just copy this. Since we are changing condition again, Control C, let this be capital, so that using and, using or. Okay, so I want to grab people where the name, Kimberly, right? Kim, Kimberly, and we want to have, let's say salary is greater than 55,000, or salary is greater than 55,000. Okay, so say or, if you look at Kimberly's salary is 52,000, but we'll still get Kimberly back. Why? Because this is an or condition, so it grabs value from both ends. So if we run that, you can see we're getting Jake and we're getting Kimberly back. Okay, and yes, you can do way more than this. You can start to do things like maybe start with. So let's say we want to pick all those rules, name starts with JA, right? So let's just see that example together. Do not forget, something is important. If we check, let's check this csv.info. Okay, let's run this. You will notice that for the text value is saved as an object. Okay, so when we're accessing them, we cannot access them as if we're accessing a string directly. Okay, so what do? df underscore csv. Let's say I want to grab employees whose name starts with let's say JA, right? So df.csv, then we'll pass in the name, then we'll say the name. Now we have to say .str first, so we're picking the string, alright. Then we'll say starts with, which we have already done before, right? The normal starts with that we know. Then we can say JA. So if we run this now, so we're getting, why is it printing? Okay, let me comment the info. So you can see it's printing those whose names start with J. Wait, J. Okay, John, this is JO. Alright, so you can see it's only picking these two people. Do not forget, you must not omit the string. If I run it this way, it tells me series has no attribute starts with. Okay, so do not forget that. Alright, so yeah, you can still do much more with pandas. You can see we're doing them in chunks, so eventually we'll still be making much more bigger data where we can now do much more with it. Okay, so how do we rename column? So let's say, for example, I want to rename column, the salary column as allowance, maybe not salary, let's just say it's an allowance. So I can say df.csv, then I'll say .rename, then I open this, I can pass in columns. Okay, then we'll pass that as a dictionary. So basically old name, okay, old name, and then new name. That's how it works. So if you have more than one, you pass, you just keep passing it like that. Okay, so in this case it's just a single name. So I want to convert salary, I want to change that to want to change the salary to allowance, right? Sorry, not a comma, a colon, allowance. Okay, so we want to print df down here, df underscore csv. Let's rename it, and you can see. Okay, now it is not showing anything, right? Because at this point, if we print it directly at this point, or let me just do it this way, I'll comment this out, and then run this again. So you can see showing allowance. But once I uncomment this and I run it, it's still showing salary. Why? Because it is not overwriting it. How do we make sure it overwrites it? We pass another argument, and it says in place, and then in place will be equals to true. So if we execute this now, it has now changed completely to allowance. So let's change to full name. Now we can rename all column at once. We can rename all column at once. To rename all column at once, we just do df underscore csv, then we say columns. So this is easy, but we must make sure that we pass in the number of columns. It must match the number of columns we have. So we can say renaming a column, renaming. You can also add prefix to columns, so renaming all columns at once. So right here we just have to pass in, so we can say full name instead of name. We want to be full name, then we want age to still be age. So let's assume we changed it earlier to years. Okay, so we could have just renamed it, and then we'll say this will be salary. So we're taking this back to salary. I want to print df underscore csv down here. I'll execute that, and you can see that I'm having the full name, age, and salary. Right, just like that. So we'll now have it. Now let's say I want to convert this to lowercase. I want to convert it to all lowercase, and I also want to maybe remove this space here and use an underscore instead. Okay, you can still do that. Just say ds underscore csv, then we'll say dot columns. Since we're targeting the column, the next thing is dot str. Then we can say dot replace. Remember, all these methods we learned already because they are string methods, right? So look for space. Anywhere you find the space, replace it with an underscore, and then we can say dot lower, just like that. So now let's see what we get. So it has no attributes lowercase. Okay, and do dot upper. Okay, let me do it one by one, probably because I'm chaining it in this case. Let's run it. Okay, so it has changed, but it's supposed to happen on a go, probably because I'm not doing it first. Let's try it again at this point. The lower. Okay, I guess it's not picking that directly, so it's not allowing us chain anymore. So I can now say df dot columns, then I'll just say dot str first, and then dot lower, just like that. Then run that, so we can see everything is now on lowercase. So if we print df underscore csv, of course we have to overwrite df underscore csv. Let's do this. Once it again. Okay, so say df underscore csv here as well. Okay, so this way we want to override the variable, or a better way to do it is to just do it in one line. So let's see how we can do the replace this in one line. By the way, do not be tempted to put this this way. So here should be, let's use the variable method df underscore csv dot columns. Okay, very important. So do not make the mistake of passing it into the variables directly. Let me just comment all of this. Okay, so it doesn't run. So if we run this, now we have full name, age, and salary. The next thing we want to do is to combine the lower and the replace in a single go. Okay, so let me uncomment this now. So we have the replace. So I'll grab this like this, then bring it to the front. Then we'll take all of this out and then we'll just say dot columns. No, not short form, dot columns. We can use this method as well to do it. Here we'll pass in place equals to true, but since we can't pass in place like this, we pass in what we use it to overwrite the existing column values. Okay, we need to override the existing column values. And yeah, let's execute this. Now you can see now it's looking nice. Full name. So we just have to call str again. Remember earlier, I think I missed that before, it just came now. I think earlier we were doing something like this. Let me run this and it was running into an error. So we just added we just had to put the str then dot lower like that. You can see we have it nice and clean, just like that. Okay, so let's move on to the next thing. Let's say feature engineering. Feature engineering is basically creating new column from existing column to add meaning to the data. Okay, so and that is what we want to look at. So let's say we want to create, for example, want to add, let's create a test first so we see how it is created. We just multiply age and salary. That does not make any meaning. I just want to use it to see how to create a new column, because we can barely do any feature engineering from this existing column, except we want to do age group, right? Using if age is this, if age is that, and all of that, right? Let's just go with the age group since we can make meaning from the age group. So we can just say df underscore csv. And how do we create it? We just type it just like when we're doing a dictionary. We type the variable name, then we'll pass it in as if it exists. So say age group, and then we'll say this will be df dot df age, right? The df age. Then we want to apply. So that apply lets us write a function inside here. Okay, so that apply, what do we want to apply? We'll say a lambda function of, let's just say x. And what do we want to do? Remember, we want to say let's look at the ages that we have. And we can say if the person is below 30, right, 30 and above, that is middle age, since we don't have older people in this case. So let's say old and young, or adult and young. Yeah, let's use adult and young. 25 is an adult, not really young. So old and middle age, let's stick to old and middle age. So we say lambda x, and what do we want to do? Remember lambda function, we're just supposed to now put in whatever it is that we want to do right there. So I can say if x is greater or equal to 30, right? Okay, before that, I must put what I want to see. So that will be adult, over 30 again. What did we say? Middle age. Alright, middle age, yeah, middle aged. So middle age if they are above 30, else we can now say young. Else we want to say they are young. I think I should be able to. Alright, is it from here? apply. Okay, good. So I can break the code down this way. Okay, good. So do not forget to just the code wrap, code break that we did earlier. So you can see df.age.apply was saying for every age, middle age, if the age is, can just use the word age so that it makes more sense to us instead of just using. So if the age is greater than 30, should be young. And do not forget that we don't have this existing. So but once we do this, we will now have it as part of the data. So run this unterminated. So young, okay, I did not close the single quotes. I'll just put it back there. And then run that, and you can now see, oh, this is young. So okay, my bad. I misplaced the what's it called? The year, young, no, this is young, 28, middle age, 35, middle age, 30, young, 24 is not supposed to be. Okay, what did I mess up here? Interesting. Let's see, what could have gone on? Oh, okay. So yeah, now this is not, if you look at it, I was using df.csv, but somehow I think we declared a variable df earlier, and that was what I used. So I mixed two different data together, and that's why we're getting that. So let me run it again, and yes, it's now correct. You see, middle age, young. All right. So this is what we have. Let's now do a simpler version of it. So you don't figure, is it this hard? No, it's not. So let's just create a new one for, let's say, gender. Oh, I think I'll leave that up to you. For you, exercise for you, create a new gender column and assign value based on their names. Okay, so don't just assign values randomly, just look at the names. John will be a male, John will be a female, Jake will be a male, Kimberly will be a female, just like that. So male, female, like that. So give that a shot. Let's just create a new column called test. So say df_csv test. Then we'll say this is equals to df age times df_csv salary. So this is df_csv. Alright, so if this is what we have, now let's print it, df_csv. I will run it. Now we can see that we have a new column, which is df_csv. Finally, since we have seen how to add columns, let's also see how to drop columns. Okay, we have quite different methods to do it. We can use the filter method and select certain columns, save inside a new variable, or we can use the drop method, or we can use the same thing we always use in the dictionary, using the del keyword. Now this will not let us we don't need to declare, so let's just say df_csv and then we'll pass in test. So in this case, we do not need to declare in place to be true. It works just like that. But if you want to use df in place, so we can say df_csv dot drop. Then we'll put in the name. salary. We can pass in another variable. Now we have to specify the axis. Axis is equals to 1. Do not forget row is 0, column is 1. So it removes that particular column, just like that. If we want to delete more than 1, we have to pass it in. Okay, this is salary. We have to pass it in as a list. So to just give a list of the column we want to remove. And the last thing is in place equals to true. No, please, no, we're not deleting this test. So I'll run the first one and the second one, and the second one should probably throw an error because by the time it gets there, it's not available again. So but let's comment it out so we see how it really works. And all of these are best done on separate lines so that it doesn't rewrite our variable every time, on separate code so that it doesn't rerun and rewrite all of this. Okay, so it's not necessary at all. So let me just grab all of this, then cut. So Control N B, paste that in there. So you can see deleting columns or dropping columns here. Right word, dropping columns. So let's run this on a drop test, and boom, you can see we ran this and this is what it's showing us. Test is gone. So now comment this out and try to run this again, and then we'll see what we get. So it's giving us an error saying, oh, test not found in the axis. That means that column no longer exists. So let me comment it out and run our data frame normally. And you can see this is what we now have. And yes, we have been able to see some basic and much more important things with that. We can still go all the way to do things like maybe starting with a particular column, starting with this. The manipulation can keep going on and keep going on and keep going on as much as we want to do it. Okay, so let me collapse all of these. These are basic operations that we should be able to do as a data professional. So sorting and filtering, selecting, sorting and filtering. Now the next thing is handling missing value. Alright, one thing is sure, in the real world of data, data is often messy, right? And this is one of the things we've always mentioned right from the days of Excel, right? That in the reality of data is often messy, often dirty, because it's subject to a couple of things, right? And in this particular time, what we're about to enter now is how to handle this data very nicely. But one of the benefits of using Pandas to handle missing data is the fact that you can handle large data sets very fast, because Pandas can process all of this data very fast for cleaning, right? And just this here listed there are some options that we can use to maybe do some data cleaning or handling, let's put it that way, and we'll be explaining them one after the other. Okay, so let's say we want to create a data set first. So create a data frame, because if we look back at what we used just here, everything's seemed clean. Everything's seemed clean. I think at this point, yeah, this is data I've been using. Our CSV file seemed clean, no missing value in there. Okay, so just create one here, call it df. Let's say df missing, then open pd first, pd dot data frame. Pay attention, it is Pascal case, capital D, capital F. Don't get frustrated if you miss something like that, so just correct it. It can be very frustrating and just like you're getting an error but typing the same thing. Okay, you really want to pay attention to that. So just do something simple. A, so we're passing the dictionary, then we'll say B, then we'll say C, Let's put that in quotes, right? Okay. So we pass in the lists 1, 2, mp, mp.man, and 4, put a comma. Then we'll say 5, mp.man, 6, okay, this is 6, 7, 8, we'll add another comma, open a square bracket, then we'll say 9, 10, 11, mp.man. Okay, so passing, okay, man is man, alright? So passing this, and we're intentionally creating values like man, okay, in our data frame. And of course we want to see it printed down here. So say df underscore missing, no, not this, missing. Alright, so I'll just use alt enter so that I can create a new code cell for me at the bottom. Alright, so you can see this is what we have. And why are we seeing this underlined, this yellow line? It's just probably because we're not printing it out properly. But the print field is also friendly. It makes it look raw, right? You can see we're having it look raw like that. So let's do it this way, and we'll move on. Now we see that, let's rerun that so that we'll have the field vibe. Alright, so the next thing we want to do now is to start cleaning our data. But before we clean the data, we have to know or find out if it is, or if it has missing values or not, right? If it has missing value, we want to find out first. If it doesn't, then that's fine. So how do we find out if a data has missing values? We can use is NA is null, right, to check if our data has missing values. Alright, so let's do that check quickly. And just say print, and just put the print directly, a formatted string, and then we'll say as missing values, and in there we'll just, let's do \n, so we print on a new line, then we'll say df underscore missing, then we'll say dot is null. Okay, dot is null. So we want to find out if there are missing values in our data, right? This is not a number, okay, not a number. So let's print this, and it's saying okay, so let's check the entire data set, and it's saying false, false, false. So not a number as well, true. So you can see that for column B, row label 1, column B, row label 1, which is this place, and this place, we have what? We have true. Also for this place, row label 2, column A, we have true. And finally for this place, we also have true. So we can see that, oh, we do have missing values in our data, right? We do have missing values in our data. We can get the total of the missing values in a column, right? How do we do that? Let's copy this, paste here, and then we'll do okay, so we'll say is null, we're just adding sum to it. Number of missing values. So this time we'll put it as a column. Alt enter. So you can see total column A, all the column, you can see it is by column. So we have one missing value. For B, we have one missing value. For C, we have one missing value. By the way, if you're wondering what the difference is between is null and is any, they're basically the same thing, okay? Is null came first, right? Is null came first. I'm just put it this way. Is null came first, more like the SQL style, right? Then later is any or came. So if we just change this now, if I copy this and then use is any, we'll get exactly the same thing, no difference at all, okay? So I use that enter, you see exactly the same thing. And we can also do it for the sum as well, so it can be used interchangeably. All right, you can see just like that. So now we have checked if our data has missing values or not. Of course, if you think back, when we're looking at or inspecting the data, you will know when we're trying to know the data, you remember that there is one method we can use to get the number of missing value. One of these when we're inspecting data, which we covered, I think, just right before this, data frames. Okay, I broke this. Continue with this part. So just right before this, you see, we can also get the total, but we have additional details in here. But if we don't want the additional details, we just go ahead with what we use, which is the is any or is null. Alright, now that we know we have missing values in our data, we just add more columns. Okay, so now that we have more columns, now that we have figured that we have missing values, so we probably want to maybe drop, let's say we want to drop the entire row for a missing value. That's if, now we must be careful of dropping records, because if we're dropping the records, which is a row, and we have many missing values in a row, we'll probably drop too many data, and this will not be good for a machine learning model eventually, because the more data we feed it with, and the more, let me use the word, the more good data, the more clean data we feed it with, the better the result we get. Okay, so but I'll just show you if we were to drop the rows, what it will look like. Okay, if we were to drop the rows, what it would look like. So let's just do that quickly to understand how to use the drop to take out missing rows, just in case you want to do this at any point. So just a df underscore, let's call this dropped rows on dropping drop rows with missing values. Okay, so drop rows, then df underscore missing, then we can say drop NA. Okay, just say drop NA. And with this, take this down, and with this we can print out the dropped rows. So just say print f, let's say DataFrame after dropping NAs. NAN, just like that. And so I just want to put it down here So that looks drop rows. Right. So you can see that this is what we have left. Now, intentionally, we use the variable y so that we don't overwrite the original table. Because if you look at this now, we should still have our full record in there. So, but because so that's why we saved it. We didn't overwrite this completely. Okay, we did not overwrite the drop any directly. So if we wanted to do that, we can pass in a value called in place, and if you look at this, it takes what? In place. I'm passing an axis if it's just now if you pass an axis, so we tell it if it's a row or a column. Okay, and then we can put in place just like that. So I remove this. This is the version of what we have after we have dropped the rows. Okay, after we have dropped the rows. What if we want to drop a column instead of a row, right? So sometimes you might want to take out columns, not because they have missing values, but because they'll be relevant to our what's it called, to our analysis. Okay, or they'll be relevant for the machine learning model we want to feed them into. We can easily do that by using the same drop that we just used, but then in this case we'll be passing an axis. Okay, so I'll just copy this, Ctrl C, Ctrl V, dropping columns. Okay, so let's drop the columns with missing values, right? Now, once we say df, this is the variable we had earlier, right? Df underscore missing, then we say drop any. The only argument we have to pass in, like I said, if you over on this drop, you can see we can pass in the axis, right? And we can also pass in place. In place is if you want to override the original variable, but we don't want to do that. Okay, and that is why we are saving it inside another variable. This is not PDF, df. So we'll just say axis equals to 1, 0 is for row, 1 is for column. So we say axis equals to 1. Then if we want to pass in the in place, we can pass it in. So we'll just remove this, and the next thing I want to do is to print it out. So we'll say print, and we'll put dropped, df.dropped. No, oh, rows, no, this should be columns, calls. Let me change this as well to calls. Columns with missing values. Alright, let's run this, and now you can see that we just have the index left, because basically all the columns have a missing value or the other. If you look at this list, column A has one missing value, column B has one missing value, column C has one missing value. So basically all our data is gone except these labels right there. See, everything is gone. But we still have our original data, however. So let's print our original data down here again, which is df underscore missing. So you can see our original data is still here. Okay, so the next thing we want to do now is, let's say we don't want to delete them, we want to fill up the values. We want to fill up the values. How do we do that? I'll do that here. Filling missing values. filling missing values. Okay, so we can fill with specific values. For example, we can fill with zeros. We can say df filled zeros or 0, right? Singular plural. Then we say df underscore missing dot fill any. The way we have drop any, we also have fill any. Then we pass in our value in here. So you can see it says value. So we pass in our value in there, just like that. So it can be a scalar value, can be this type, any type, it can be dictionary, it can be series, it can be data frame, whatever it is we want. So we have passed it in, okay, and then we can print it out just to see df field with 0. Alright, so that's df field 0. We don't need to put any special prints there. You can see it has filled everything directly with zeros, just like that. Now it can happen that we probably want to fill with the average of that column, right? It's possible that we might decide to fill with the average of a column, right? How do we do that? Fill with mean. Mean is the same as average, okay? So fill with mean of the column. So we can just say df field mean, then we'll say df dot missing, df underscore missing, I mean that's our variable name. So df underscore missing, then we'll say that fill any. So the fill any, if you ever on the fill any, alright, that's just the network. Let's wait a little. So now, okay, let me type that again. Fill any, and over on it. I just want the documentation string to come up, but let's continue regardless. So in this case, we'll just say df dot missing, df underscore missing, I keep saying dot, df underscore missing dot mean. Okay, so we're passing the mean. Now we can pass a variable called numeric only. Okay, since we are trying to do it across the entire data, so we can say numeric only, and you can see it right there, numeric only, and that will be true. So we'll say true. Okay, so numeric only to be true. So we'll say df dot field mean. Okay, so df dot field mean. Yep. Then we'll execute that, and then we can see. So it checks. Now for the column, look at our original data and print our original data down here. df we don't have any data like that. Df missing. Okay, so you can see here we have 7, right? Then when we, if you check the average of those 3 numbers, that's 1 plus 2, that is 3, 7 divided by 3, that should give you 2.33 that you have here. This is 20 divided by 3, so more like 21, 7, so that's 6 point something, and that's what you have right here. And for this is 30 divided by 3, so you're getting an accurate 10. So it's able to fill the column, individual column, with their mean. However, what if you just want to work on a single column? What if you want to work on a single column on a specific column? Specific column. So if you want to do the replacement on a specific column, that means you have to say, let's say df field column C, let's say column, let's say just to column B, random column. So column B, then we say df underscore missing, then we pass in B, right? So we're saying for this particular column, fill NA, and what is it going to use to fill the NA? We want to use the value of that same column, right? We want to use the value of the same column B. So just say df underscore missing B, just like that. Then put dot name. Okay, so let's print this. Just put it down here, df. Okay, I think we can bring that up into a separate column. Paste here. Then we have df field column B. And you can see, if you look at it, it's exactly doing exactly the same thing, right? What if we want to fill for a text column? Because I've been working on a number column. What if we want to fill for a text column? So we can also df underscore missing, df underscore missing. Let's create a new column. Then just say this column will be D. So let's say D. Then we'll just say np.man. np.man. So if we print the df underscore missing now, send a couple of them, df underscore missing. So you can see we now have a new column called column D. So let's say we want to fill column D with text, alright? We want to fill column D with text. So we can say, just like as you are the ones we have done, it's no different from that. We just do our same D fill. So df field texts D. So that's for column D. So we can say df. Now since we are working with a specific column, so we say df underscore missing. Now you don't forget that for us to do that in this place, we say this another variable, but if we want to overwrite it, we have to put in this variable on the left. Okay, but since we are not overwriting our original array, we'll just say D. No, we don't have S, it's a D dot fill NA. Okay, then in here all we want to do is pass in column D. Let's just pass in the text column D. Now the df field, let us now let this text. Okay, so we're saying fill that column with a text. So it's showing column D, column D, column D. That's just it. We're only working with a single column. So it's showing all column Ds. What if you want to work with two different columns at a single time? Right? Let's say df field multiple multiple. So we'll say df underscore missing dot fill any. Now in here we'll pass in a dictionary. Okay, and then we'll say let's say for the first one now, which is going to be A, capital A, or let's create 2 new columns. And we can create for, okay, we'll fill in C again and D with another value, right? So we'll fill in C again and D with another value. Since we already have, I hope we created this on the original array. Yeah, column D is on the original array. So yes. What do I mean by that? If we look at our df missing, the original df missing, oops, so if we look at the original df missing, you can see our D is still there with the nan. All the nans where we have them are still right there. Okay, so passing the first column, which is C, and this is a dictionary, right? So we can expand this so that it's you can see it more properly. So say C, go back up, then we'll add a column. What value? So C is the key, right? If you remember the dictionary vibe, C is the key. What do you want to replace C with? We want to replace it with df underscore missing column C. I want to take the mean of column C itself. Then mean, open and close, take this out, nope, take the extra quotes here out, alright, and this is a dot, not a comma. I'll put a comma down here. Then we'll say for column D, let's say I want to pass in the value empty. It could be a text, it could be another. Now this one is an operation and this will be a text, empty. Empty. So this is what we want to pass in for column D. So we can say filling multiple columns with different values. Multiple, okay, multiple columns with different values. So we can come down here and say df underscore field multiple singular. Okay, yeah, this should be fine. And you can see just like that, it filled this correctly, it also filled this correctly for us. Okay. Okay, so we'll do the forward fill and we'll probably just get a warning because this is the way it's supposed to be. Let's just check that out. Alright, that's correct. And you can see what we have. So we did a forward fill. This became 2, this became 5, this became 11. So let's try that with a backward fill and see what it's going to look like. So I can just copy this, then I'll paste right here. So by the way, we're getting a future warning that df fill any with the method is deprecated and will now raise in future version. That means in the future version, we will be getting, what's it called, an error. It will be raising an error, it will be raised as an error, but now it's just a warning. Okay, so and the way we do it now is what, we don't need to put that fill any, we just put the object itself, which is this, and then we do dot fill, backward fill dot forward fill, and that's what we do for this one. So say bf, then instead of fill any, I just take all of this out and then do a b fill, right? And this is all. So now print out the underscore b fill, then run that, then we can see what we're getting. Now because there's nothing in front of this, there's nothing to fill it with, right? You can see earlier this was 2.0, this is 4.0, right? This 2.0 is now doing a backward, so it's now 4.0. This, it was 5 here, it is 7 here, and this is just n here, right? There's nothing to fill it with. And in this case, there's nothing to fill any of this with because there's no valid value in column D at all. Okay, there's no valid value in column D at all. And yes, with this, I think we've quite covered much how to undo missing values in a data using Python. Yeah, so we've covered how to undo missing values in data with Python. And of course, sometimes we'll have duplicate values. So we're seen how to undo missing values. Sometimes we'll have duplicate values. Now this will have like tagged data cleaning or something. It's okay. So we want to see how to undo duplicate values in the data. Okay. So I'll just list them out as we do not have a data set to demonstrate them yet. So let's just assume we have a sample data df or df dupe, right? So to use it with this dataset df dupe, all we have to do is, for example, to first check the same way we did for his NA, we say df dupe dot duplicated. It is a past tense, right? Duplicated. This should be duplicated. Now we say df dot duplicated, and for us to do so, this will check boolean true or false. Checks for duplicates. Checks for duplicates. Okay. Now, what if we want to drop the duplicate? Of course, you can drop it inside a variable, as we've always seen, and you can drop the result after dropping the variable. What I mean is this. Let me just clarify that. I mean, just like I've been doing this, right? All the operations, I've been saving the new operations inside another variable. Exactly. So that is what I mean by that. So you can say df dot dupe, and we can say dot drop duplicate, and this is plural. Hold on, I don't need to run that because we don't have this variable. I'll just like clear. Okay, so say dot drop duplicate, equals to shift, removes duplicate across all rows. Okay, this is an all row duplicate remover. Okay, now if you want to remove duplicates across specific columns, you can say df underscore dupe, then we say drop duplicate again. Just copy and paste. Okay, drop duplicates. Inside there, we now pass in an argument. Let's see if the doc. Okay, doc is not coming up. So in here we can pass in subset. Then we'll pass in a list of the columns we want to check on. In this case, we'll be passing in a list of the columns we want to check on. So I want to say full name and the age. Okay, I want to say the full name and the age. So drops by specific column, by specific columns. Okay, and finally we can keep the last duplicate value we find. Okay, so we can use this on either a column or for the rows. The only difference is to keep the last row. Let's just say ID, for example. ID, for example. We say keep equals to last. By default, it keeps the first. So if you want to keep the last, we say equals to last. Control C. If we want to remove both of them, that means all the occurrences, by default, it keeps the first one. And then any other thing that repeats, it takes it out. But in some cases where, for example, it's duplicated due to update in value, of course, that will be because of the system design or the data system design, whereby, okay, someone updated their email address, so it duplicated their entire record. But the latest one is having the updated record. So in that case, you might delete the previous one. So you can say delete first, right? So keeps the last duplicate dupe found. Yeah, keeps the first. Keeps, let me just put default because that's the default. Keeps the first. And finally, if you don't want to keep any of that, let's say keep is equals to false. Alright, let's look. Then we'll say removes all occurrence of duplicates. Okay, so this removes all the occurrence of the duplicates. Okay, for some reasons I feel it's best we demonstrate it. So let's just create a data frame for it. Now say df equals to pd dot data frame, open a bracket, now pass in a dictionary. I'll do that, pass in a dictionary, then we'll open it up. So we can just say name, Alice, Bob, Alice, Charlie, Alice, Charlie, let's say Alice again, Alice, Darwin, Alice 1, Alice 2, Alice 3. Let's also repeat Bob for once. So this is what we have, and we do the split, so it becomes a list for us. I'll put a comma, then we'll say age, then we can put in 25, 30, Alice is 25 again, 25 again. Then we can do Charlie. Charlie should be let's say 35. So we have to match it. So Alice 30, Bob 30, Alice 25, Bob 30, Alice 25 again, Charlie 35. So Alice again, Alice is still 25, Alice is 25. So Darwin can be 40. Darwin can be 25 too, by the way. Darwin 40, and Bob is the second person, 30. So let's look at it. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, that's correct. Now put a comma. Then we want to say city. We just use some US city short code, NY, LA, then we say NY again, because that's for Alice again. Then we say CH, then we'll say ny again, then we'll say sf, then we'll say ny again. No, would that be ny again? No. So this is Alice, Alice, Bob, Bob, Alice, Alice, Charlie, Alice again, Darwin, and then Bob, right? So the last one will be for Bob. So we can just put Bob for CH as well. Okay. Alright, so let's print this out to see what it looks like first, and then we'll say df, and we'll see what that looks like. Now we can just do dv or px for this guy. Let's do dv. Okay, so it kind of match except for this. Oh, we're having an error there, so let's DataFrame. Okay, so this should be perfect now. Alright, and this is what we have. So this is what we have, the age city. So let's add some code cells. Now the first thing we want to do is to check if they are duplicates. Now in this case, since you don't want to start creating variables and overwriting them, we can just print them directly. So let's do print of the df dot duplicated, because we want to check. So duplicated, and like I said, it is past tense, not duplicate or duplicates. So run that. Hold on. You can see what we have. False, false, true. That means third row is a duplicate of the first one. True, duplicate of another row. Then we have false, false. Okay. Bob. Bob. Oh, I use dv for Bob. This is the person I let's use dv for. So you can see that it is checking the entire row, right? That's the first thing. Before I change it, you can see that it is checking the entire row, because Bob here is 30 but stays somewhere else, right? Bob here stays somewhere else. I think it's cool. We can just leave it that way. So ny is duplicated. Alright, we're good. We're good. Now let's say we want to remove duplicate. Now if we draw duplicate, do df dot drop underscore duplicate. Okay, just run that, then execute. So you can see that's removed duplicate for us, clean. So we removed Alice, or the repetition of Alice. We're only having Bob again because it is not an entire row duplicate. Do not forget that in removing duplicate, we can do row duplicate or column specific duplicate. Okay, so it has removed the ones that match the entire row. Okay, so what do you want to remove? Specific column specific duplicates. Right, just copy this, make it faster. I'll paste here. Now say in here, so we're passing what? Subset. No, it's not correct. Sub has nope. Subset. Okay, and you can see that automatically came with the equal to that will pass in a list. And so one the name, comma, the age. Okay, so I'm dropping duplicates on these two columns. Let's run that, and now you can see we don't have the second Bob anymore. So we're checking duplicate based on the first two columns. And you can see how simple it is to do. Right, how simple it is to do. So we can now do the keep last, keep first, keep this, keep that part of it, and say we don't want to keep any of the duplicates. So let's see how, if we don't want to keep any of the duplicates at all. So Ctrl C, Ctrl V. Let's say keep equals to false. So I'll leave you to try keep first, keep last, so that you see how that looks like. And you can see all the instances of the duplicate are gone completely, right? So feel free to put in first here and last and see what that looks like for you. So with this we've covered handling duplicates. So close that, and now we want to move to data type conversion, which is still part of our data preparation stage, right? Because when you get data, you want to find out what is in your data, you want to clean it, you want to make it ready for analysis. You want to make it ready for analysis. Okay, so let's jump into it now. Ensuring our columns have the correct data type is very important for memory usage, right? Very important for memory usage, but much more for analysis, because if the data type is wrong, we will not be able to carry out accurate analysis, right? We've seen how null values, I think when we're looking at numpy, we're trying to take a sum of a column with null values, and then it's just not letting us do that, right? It's not letting us do that. So data types are important, and somehow I feel we've covered text string manipulation or so, but no, I don't think so. We haven't done that, not even in the basic module. So let's just continue. We want to see how we can convert from one data type to another, because most times we don't determine the data type, right? We don't decide the data types that come with the data. So but we can correct it when we need to. Okay, so just say DataFrame for types, then we can create a dictionary again, pd.dataframe, a 1 2 3 b, let's just do 1.1 2.2 3.3, then we'll split it, dot split, that will give us a list as well. Then finally we want C, we want a boolean in this case. By the way, it doesn't matter, you can use double quotes, you can use single quotes. So let me use double quotes here. Okay. Finally we want a boolean, so say since we'll split them up, but we'll make it a text first, so we'll say true, false, and true. Okay, then we'll also split it up. Okay, so let's print this data type to see what it looks like. Okay, so you can see what we have. But everything, obviously, from the way we created it, is a text, right? Everything is a text. So let's add some new code cells. So if we check df underscore types.info, so you can see only the first one is an integer, so remaining two are objects, right? See, integer, object, and the second one is supposed to be a float, while the last one is supposed to be a boolean, right? Last one is supposed to be a boolean. So let's see how we can correct all of this with Python. So I'll take this out, clear the cell output, then we'll type in right here. So say df underscore types we've had a lot of dfs. So df underscore type, like I said, this is supposed to be a float, but it is individually string. So I want to say df.type, then colon b, because we want to overwrite it, right? We want to override the original variable. I'll say df underscore types, in quotes, put in b again, then we'll say dot as type, alright? So pass in as type, and it takes what? Says it takes the data type we want to pass it as. So just put in there, we'll say float. So now we can print the data type df underscore d underscore types, okay, dot d type. Alright, so we want to check the data type after converting it, and you can see the now is now what? A float. Earlier we have it to be an object, just like this. So you can see it has now converted it to a float. So we want to do the same thing for boolean, which is easy. And just copy this, then we'll paste it there, then we'll say c, then convert it to what? To bool. Then we're going to print the types again. You can see it has now converted it to a boolean. Okay, so we now have it as a boolean. So let's say we want to do some let's say some conversion that we need to handle error. For example, we want to do a numeric conversion. We can use the coas to suppress errors that cannot be converted. What does that mean? Let's look at it. So let's say df numeric underscore error. So we have pd dot DataFrame. Just want to pass in something simple. So just say column. It's just a single row data anyway. So I want to say 1, 2, ABC, 4, mp.nan. Okay, so we have all of these values. Okay, so if we print this down with df numeric, okay, df numeric error, and you can see it's just a single column, right? Just a single column of data. So we want to be able to convert this error from what it is, right? I want to print it out. So let's see what that looks like. We'll say df underscore numeric error, then the colon, so equal to pd to numeric, then in bracket pass in the colon, df numeric error. We have just a single column, by the way. Now this is what we want to convert. Then we'll run this and see what it will look like. Okay, df numeric So you can see what it's saying. It's saying, oh, I'm trying to do what you want me to do, but I cannot pass this as a number. I can't seem to do that. There's no way I can do it. So we want to be able to undo that error, right? So we have the coerce option to undo that. So we can say errors. So we'll go back to this place now. Let's look at PD numeric. So you can see the first thing is what we want to convert, and then the second thing is the errors. So it says the error. So right here we can say comma. Let's see what we're typing. Okay, and then we say error. So for the errors, we say we want to coerce it. So we'll say coerce. Is that how to spell coerce? Coerce. Yeah, that's how to spell it. So we run this again, and now you can see we have been able to successfully do that. So that particular one has been now passed as none. So you can see now we have handled that kind of error. So if there's a specific kind of error that can crash the conversion, it just passes it as not a number, because this is a numerical column. Okay, and what the word coerce simply means is to force, right? To use force, to force the attribute, the data type, to take on another one. But the word coerce means to use force, threat, whatever it is. Okay. Alright, so let's collapse all of this. Our data type. Now let's jump into grouping and aggregation, which is very important. Now when we're talking grouping and aggregation, of course we did similar in SQL, with the SQL is still ongoing, and we did same thing in Excel. Now in Excel, in Power BI basically uses grouping and aggregation. Excel we have an intermediary which is called pivot table to do the grouping and aggregation ourselves. Okay, so in this case we want to group data. Then for example, let's say we have gender. Now column, we want to see how many male, how many female. That is grouping. Immediately we say how many male, how many females, right? We're saying males and female. Once we bring gender into it, we're automatically grouping them, separating. Then we want to do aggregation, which can be a count, a sum, min, max, and all the rest. Okay, so we look at grouping and aggregation. We'll create a new data frame for that as well. So just say sales data this time. And let's put it as pd dot DataFrame as usual, once and for all, open, close. So I don't think DataFrame DF is what we must always use for our variable name. Okay, so now we are using sales data. So we can see the region is, so I'll say north, south, north again, then we'll say east, then we'll say south, then we'll say east. So we'll do a dot split, so that becomes a list, right? So we're not passing a list at that point. Then we'll say product. So product, let's say laptop. Let's say mouse. Then we can say laptop again, laptop. Then we can say headphone. We can say their products, let's say um, so let's also say type C USB hub, type C. Now in this case, because I probably don't want it to split on that, so I'll say type C USB hub. Okay, then we can say laptop stand. And then do we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Again, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5. So say laptop stand. I just use underscore so that it doesn't split on that. Or you can see laptop stand. Just do it another way, so we don't end up doing some replacing. Okay. Type C USB hub. So that means right. Let me separate with an underscore then. Laptop stand. Oh, our normal comma. Okay, since that's symbol logical. Comma. 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 And comma. Okay, just like that. So we have 1, 2, 3, 4, 5, 6. So then we do our dot split. So this time we're telling it what to split on, and that will be a comma. So we're saying split on the comma. Let me see if I can break this down this way. Okay, so we're saying split on the comma, and finally we want to have the sales value. Let me put the comma. Okay, so say sales. Alright. Sales will have some figure. Let's say 100. Or let's say 500. Then we'll say 50. Then we'll say 500 again. Let's take this out. So then we'll say 250. Then we'll say 75. Then we'll say 110. 110. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so this is the data we want to use, and let's just print out the data and see what it looks like. As usual, we print our sales data. Sales data. So you can see, so it did the work nicely for us, just like that. Right. So what else do we want to do? Now that we have a data, we can now try to do what? Run our what's it called again? We can now try to run our grouping and aggregation. For example, on C, total sales by region, things like that, or total sales by product, and the rest. But just before we jump into that, I would like to rename this to lowercase all the columns. So we can do sales data dot columns. Remember we did this earlier. Okay, so just say sales data dot columns, then we'll pass in the data. So it's more of a reminder for our what's it called now, our data cleaning process. So we just looked at handling missing data, handling duplicates, correcting data types, so cleaning up data as well, whether we're doing some string manipulation and all. We can also check that. I think we did that somewhere in here, right? In here, so we can check. Yeah, right. This is filtering. Now you can see this is the point where we did all of the remaining columns. We also did feature engineering, right? Then we also did dropping columns, right? We also did dropping columns, but this is not necessarily a null column, right? An empty column. What we did later is dropping empty columns. Okay, so you can see this is what we want to do. You just pass it in like that. We'll see all at once. It just replaces everything. So in the DF, we now have these columns like this, right? Just say the DFs, we now have the columns like this. Okay, so I think I should include that in here. So I should be selecting, sorting and filtering, remaining columns, after remaining columns, we also did dropping columns and dropping columns. Alright, so we can collapse this, go all the way. Okay, so this is where we're, let's close this. This is where we're renaming our column. Okay, we don't need to repeat this. We're saving or overwriting the variable. Then we say name, product, region. Region first. My bad. Region, product, and then we'll do sales. Okay, so if we print sales data again, sales underscore data. Okay, so we have now been able to rename everything at once, right? So if we want to rename individually, then we'll pass in, we'll open a bracket for the columns, and we'll pass in a dictionary of what we want to change. All right. So let's jump into the grouping and aggregation. So I'll just create some cells down, Ctrl B. Let's just add more. We'll add a couple of them. Okay. How many do we have here? This is more than enough. So let's start with the regional sales. So let's say we want to see total sales by region, right? So all we have to do is, let's say, that will be group by region, and aggregate by sales, and aggregate by sales. So you can just say total sales by region, which is a variable name where we want to save our results, will be df sales data dot group by. So where do we want to group by? We want to group by region. Now since we are grouping by region, what do we want to aggregate by? That will now come in square bracket right in front of it, and that will be what? Sales. So put in sales. So we're saying group by region, aggregate by sales. So we just put dot sum, as we're taking the total sales, which will be sum of sales. So if we print this down here, you can see what we have. See how nice it came out. So we have region, and then we have sales, just like that. So we can see region and we can see sales. Now if you look at it based on calculation for east, we are seeing 360. So let's see east. That's 250 plus 110, and that's correct. We're seeing north. North is 1000 because the two laptops are from the north, and south is 75 plus 50. That should be 120. 125, yeah, not 120, 125. So we are able to what? Group and aggregate. What if we want to group by two columns at once? Okay, so we can say okay, let me copy the comment as well. Okay, so what do we want to group by? Region and product, and then we aggregate by the sales. What do we do? Inside there we pass in a list. So region and product. Alright, so we pass in region and product. So we can call this sales by region product. So let's bring this down here. Do not forget the variable name, then group by. If it's just a single column you want to group by, you pass in another column. If you want to aggregate by multiple columns, you pass in the multiple columns. Now unlike SQL where you have to select and then it tells you, oh, if you're grouping by this, you have to aggregate by this. If you're aggregating by this, you have to group by this. And maybe by default you cannot tell. In this case, it lets you know, okay, what are you grouping by? And then you now show what you want to aggregate by. Okay. So let's see what this gives us. And you can see, so east, for the two times we have east, headphone, laptop stand. Then for north, it's just laptop. So that's why it's a single product. You can see 1000. For south, we have mouse and USB. Just like that. So we can go by two columns. What if we want to aggregate by more than one column? Or we want to perform more than one aggregation on the sales. Let's say we want to get the for example, we want to get the sum, which is the total. We want to get the average, and we want to get the number, right? Or we get the count, something like that. So we can just copy all of this. Group by sales and aggregate by sales with multiple option, multi. Okay, just so that there multiple options. Now here we can say aggregate. Now by hovering on it, you can see it's giving us some nice visualization. It's giving us the total summary of it. We have the artificial intelligence option turned on for all of that. So say aggregate by sales, AGG by sales, aggregate sales, group region. So let's put it this way: aggregate sales, group region. So I'll copy and paste this down here. So we can always use the print to show it in the raw form. Okay, can always use the print to show it in the raw form. Now instead of doing sum directly, we'll say AGG, which is an aggregate. Then inside there, we can now pass in sum and say we want to get the mean, and say, okay, let me just break it from here. To break properly. Okay, sales.group by Okay, so then aggregate. Let's try an error already. Let's say let's do regardless, and then we want to put in a count. So this is what we have, and then we want to print the result out to see how that looks like. So we're printing what's aggregated sales, but the way we broke the code into separate line, yeah, so the group by is not getting the group by option correctly. Or if I break it this way instead, alright, let's leave it on a single line the way it is. Let's just put everything on a single line. Then execute it, and now it's printing out correctly. So you can see it's now printing out correctly. It's just the breaking that it's not getting properly. What if I do it on a single line? Okay. Now it's already showing an error. Let me indent it. Still showing an error. Keep it on a single line. Okay. We'll keep it on a single line like that. Run it again. And you can see what we get. So for east, sum is this, average is this, count, that means number of products in those places, right? We have number of products in those places. Alright. Well, having come this far in this particular channel, you will notice that we know better not to leave our results like this. For example, we're saying sum of what? We're saying mean of what? We're saying count of what? Right? It does not really make sense. So how can we make sure that we properly display our results? I'll copy all of this. I'll paste it in this new cell. And all we want to do here is simply display our results properly. Okay. So in this case, I can bring this down. So that should be able to break properly at that point. Then I'll also do like this. Put it like this to work. Now since we have sum and everything, so we'll say total sales will be equal to this. So what are we aggregating on? Sales. And what aggregation do we want to perform? Sum. Then we'll do a comma. The next thing is average sales. Then we'll open this. Then we'll say still the sales. So you can see you can aggregate different column as well. So but in this case we're still aggregating the sales. And then we'll say we're doing a mean. And finally, I'll say number of products, number of product or quantity. So say number of products. I think it's number of product because in some regions we have different products. So number of product, not quantity. Right? It's not a specific product. So we'll do this, and then we'll say, and let's count product. Then we'll say we're doing a count. Okay. Now we can take this out. And okay, everything is okay. So we can just call this aggregated sales, AGG sales. Let's put it this way. Put this AGG sales right here. Okay, so let's see what this looks like. What are we missing? Okay, type error. Function expects to receive tuples in keyword arguments. Yep, these are tuples. Okay, these are the keywords. Okay, let's look at it together. Okay, first of all, we have this. So this does not probably exist, but the error is, I think the error is not reaching it first, right? It's if we comment this out, I will run it, so it's telling us that this is not found. So that was because of the underscore earlier. Undo that, so you can see, if you undo it again, you can see there was an underscore here, but that is not the error. So what means it's mean, not means. Well, this error happens and you just have to like look through the code again. So what else did I miss? We have sales data, right? 1, 2, 3. So we're still getting the same thing, and it's pointing to the first line now. So aggregate sales by. Well, since the error is coming from the first line, this first line. Okay, all right. So I already specified sales here, and of course so far is picking sales, but on getting to product, sadly is not pointing it out to me. On getting to product is not part of what is listed there. So what I can do is take this out completely, since I'm performing aggregation on another column. So I can take this out completely, or I list it inside there, right? And then this should run without any error eventually. Okay, so that was the error that occurred before. Again, let me show you. We passed in sales here, but we're aggregating another column, so we can just remove it completely, and then it automatically knows that okay, this is the column, this is the function, this is the column, this is the function, this is the column, this is the function, and it's not looking for it anywhere else. And you can see how nice this is. And we can also add a keyword called reset underscore index. Okay, then run that, and you can see. So by resetting the index, we're now having it, instead of the way it was floating, it's now properly on the same line, right? So I remove reset index. Let's just do that separately. Okay, I'll copy all of this, Ctrl A, Ctrl C, take this out, run it again. Let's just hold on for the networks coming up now. Why is it taking long? Runtime disconnected. Okay, it's now connecting again. Right, we'll execute that. Good. You can see how it's floating. And if we put this here, and then we'll do the reset index, it's now properly appearing in here right now. You can see this looks nicer and cleaner. We can easily tell this can be instead of number of products, can be order counts, right? Order counts, or count of order, anything. All right, so this is better. So let's look at the one we did earlier, just a single aggregation. So as usual, now you can now reset this index. You can reset this index, but this particular one, let's reset the index, since it's just a single aggregation. Where is it? Okay, this was our data. Then we can do reset, now it's called index. Then we'll say name equals to total sales. total underscore sales, and then we can run that, and then we can see now it's properly showing. So as a challenge, or not necessarily a challenge, as an exercise, we set all the index of the rest and give them a proper name as you have seen. Okay, give them a proper name as you have seen. And yes, we have been able to do grouping and aggregation on single column, multiple columns, multiple aggregations, resetting index, so that we can have a clean, good result. Okay, right. Let's collapse all of this and then look at pivot tables. So look at pivot tables in Python. And how does that sound? So the first thing is, let's create okay. I don't have this here, not sure. Let's cut this out. So we'll be creating another data set as usual. And let's call this sales data again. TFA store. Alright. So this is TFA store data, and then we'll just do pd dot DataFrame. Pass in the dictionary, we open it up. Then we can say branch. Lowercase. Can say cities. Let's just say cities. Then we use some random cities name. Clatos. Then circle. Then we'll say circle again. Then we'll say Clatos. Another city to reload. Okay, we can just repeat. Okay, Palamuta. Alright, so these are city names, yeah, of a very great country, of a particular state, in a very great region. Okay, and of course we do our dot split, and then we do that. Next thing I want to put, let's just say sizes, maybe shirt sizes. Let's do something differently. Shirt size, I mean, how does that even relate? But yeah, it does. So we want medium, we want large, medium, large. Let's say large again. Let's say medium. Let's say small. So this is 1 2 3 4 5 6. 1 2 3 4 5 6 7. Okay. That will have 6. So let's make this small. Alright. So we have small. I'll do dot split as well. And finally, we also have the sales in dollars. Alright, sales in USD. That will say 100, 150, 200, 250, 300, 100. Okay, let's just put it that way. And we want to check what we have. TFA store. Okay, nice. So you can see that we have all of this city, and we have them as a data frame, right? We have it as a data frame. So the next thing I want to do is to use pivot table to summarize all the data. I want to use pivot table to summarize the data. Let's see what that looks like in reality. Okay. Oh, let's print raw data. hyphen the analytical flow, analytics flow store, okay, backslash n. All right, then we'll continue with what we want to do. So that way, now we'll say let's save it inside another variable. Say pivot summary, or pivot summary. Just finding how to decide on variable name. Pivot summary. Then let's push this down. Then we'll see what's the variable name again. TFA store. TFA store dot pivot underscore table. You can see it already. So say pivot underscore table. I want to pass in the argument. So if you look at this over on it, it says values, it says index, it says this. Now that's the value is what we used already. So this is the values. So the next thing we proceed to pass in is the what? The index, right? The index is the next thing. And do not forget that for index, they appear this way. So basically index will mean rows. So what do we want to use as rows in this case? Okay, so we say index, and then we say our cities. Cities will be rows. Then we can pass in column. Say columns. So if we go back here again, see we have index, we have columns, we have aggregate function, right? So we say columns. In this case, we want columns to be shirt size, right? Yeah, shirt size. And then want to pass in values. In this case, that will be sales in dollars, because now we're doing it as a keyword argument. Okay, we're using it as a keyword argument, so we do not necessarily need to follow the order that is in there. So next thing we're going to pass in is the aggregate function. Aggregate function, and in this case we just want the sum. Okay, then the default is a mean, so yeah, mean. Alright, and we have margin, by the way. We have margins, and we'll check it out. What else? Yeah, I think we're good. And then we can say print sales summary. Alright, and then down here I want to put in pivot pivot summary. Okay, so let's see what that looks like. And now see what we're getting. And so we're getting the shirt size, getting the shirt size at the top, right? Cities. So for this particular city, the search, we don't have small shirt size, we don't have small, we don't have large here, we don't have large here. So let's see if we take out the columns, run it again, and see it's just giving us a basic feel of grouping and aggregation. So explore it. Let's pass in margin. So margins The margins, as yeah, margins, and then say true. By default, margins is true. So what do we get with margins? We get the summary, not the summary, column total and row total. Okay, that's what we get for us. We get the column total, and you can see that it was able to escape the NaN intelligently. So we get the row total and column total. But if we don't want that, you can just take it out completely, and the default is false. Okay, you don't get the row and column total. So which one would you prefer? Pivot table in Python or grouping and aggregation in Python? So let me know in the comment section below which one do you prefer, which one do you feel is you're more comfortable with. Will you be more comfortable with the pivot table which you're used to, let's say if you have an Excel background, or you prefer the group by and the aggregation? Yes, and finally we're about to look at join. Okay, so let's collapse this simply. Now finally we're going to look at join, then we'll look at some hands-on exercise where we now put together what we've learned or learned in units. Okay, so joins, which is merging in Python, is the same as the SQL join that we know, or the right join, left join, inner join, full outer join, right? We'll just create two data sets, and let's just say others. So we need two tables in this case, pd dot DataFrame, other ID, one to 6. So this gives us a 1 to 5. We'll just do 1 to 4. Then we want let's say customer ID. Okay, that should be in quotes. Then we'll say we want it this way too, but it will be in so let's say 101. Starting at 101, I should stop at 1. No, we want to do duplicate, so let's create it ourselves. 101, 102, 103, and 102 again. Okay, so an amount then we can say 250, 180, 320, and 90. Let's say 90. Okay, so this is what we have for others. Let's do for customer, just below it, customer equals to pd dot DataFrame undo that first. So open a dictionary and then we'll pass it in. So we'll say ID, or let's say customer ID in this case. Then we'll still correct some things later just to show it properly. So for now, customer ID 101, 102, 104. Okay, in the ID should be text, so just split it. Dot split right. Okay, dot split. Okay, so what will this do? It will basically split this into a list, and it splits on the comma, right? Splits on the comma. That's what we have in there. Right. You can just like close it up. Okay. Alright, so we have the customer ID, comma first. Then we want to have the name. That's the name of the customers. Then we can say Alice, Bob, Charlie. And the split again. So we have just 3 customers. So we're not passing anything in because it splits on the space by default. Then finally we can remove the comma up here. And finally, we want to pass in city, you can just come up with some random abbreviation for the city. You can say AB, the next one is BC, and the last one is CA. Alright, this is where these people live. Then we'll do a split as well. So we have a full list, and then we'll print both data. Just add some column. The others, then we'll print in customers right there. Yes, customers. Okay, so remember to change this as well. Customers. So run this first. That's done. We'll run this again. Okay, then we'll run the next one. Alright, so we can see that we have the IDs, and we have the cities of these people. So what we want to do now is combine the table, right, to perform some operations. So you can say we want to see the total amount of or total spend of each customer. How much have they spent on buying from us so far? Or we can say we want to see total sales by city. Can be anything at all. But in this case, we specifically want to demonstrate join. And do not forget, before we move on, we have customer with ID 4, but we don't have it here. And we have ID 3, we don't have it in the customer list. Okay. Now, in reality, this is not supposed to happen, because we're not supposed to have a customer with this ID and not on the customer's table, right? That's not supposed to happen. Except, let's say, maybe the customer deleted the account and there was no cascade effect. That means it didn't delete the entire record of that person, and probably just an existing record from before. So, yeah, cases like that, it can be. Okay. Because it's still a valid sales that happened in the past. Even though they deleted their account with us, we don't want all the records gone. Okay. So we can start with the inner join, and the keyword is just how. We pass in the keyword how. So just say PD. That's pandas itself, or calling pandas itself, and we say .merge. It doesn't use the join. .merge is the word. Okay. So if we look at the PD.merge, just one, let's come here. So already saying left, right. We know it's missing. We want you to load the docs for us. Alright, let's just type in where we want ourselves. So the left table, others, the right table, customers, and then we say on. What are we joining on? As usual, in this case we're joining on customer ID, and then we can say how do we want to join it, or how do we want to join inner. So this is what we have. So left, right. So let's see what that looks like. Okay, runtime is reconnecting. Okay, and just like that, you see that we have our table printed. So the ID. Now what do you notice? Take a minute, study this table. Just pause the video, take a minute, study the table, and tell me what you notice. If you notice, you will see that we cannot find ID of 103 and 104 on our table. Why? Because inner join returns corresponding records or matching records from both tables, right? And we don't have 103 on customer table, while we don't have 104 on. I mean, we don't have 103 on customer table. Yes, that's correct. And we don't have 104 on the others table. So let's see. What if we do a left join? Okay. What if we do a left join? Run this, and you can see now we have 103, but we don't have 104. That means 104 has not made any purchase at all. Now the 103 as apparently shows that, oh, we can easily tell that, oh, we have a ghost customer. But of course, except it's understandable that they deleted their account, they're no longer with us, right? So you can see that they don't have a name and they don't have a city, but we can see what they purchased. In this case, others table is the left table, which is the primary table. If I change this to right, that makes customer table primary, and we will not see 103 anymore. Okay, so keep it on left, and that is what we want to see. Now what if we want to keep everything, right? We want a combination of everything. We don't want to lose any data at all. We can do an outer join. So we can just say outer. You can see in this case we have 103 and 104. Everything is complete in this case. Now what are the other useful options we can have? So I'll copy this code up here. Okay, and I'll just change it to order and customer. Just make it singular. Okay, now we'll run this. You already know what is inside. Oh no, let me rerun it. Now in this case, I will name this ID. Okay, I want to name it ID. So we have ID here. We have it as customer ID on this case, but these are common cases where we can have data to appear this way. So we run that. I want to see how do we join now that they have two different names on the two tables. So we'll just say let's just copy one of our codes. Let's copy the left code, Ctrl C, Ctrl V. So right there we can just break this open and break this open as well. Now we have to now say, instead of just saying on, we'll say left on, then we'll say another one, specify right on. So you can see we have right on. So we're saying join on the left using the customer ID, join on the right using the ID. How do you want to join? We want to join using the left ID. So right on the ID. Okay, I think I'll enter the comma just before the how. Say perhaps you forgot a comma, that's syntax error. And yes, I did forget a comma. Okay, what else do we have? Key error ID, check for duplicate. So let's look for it. So in this place on the right, we have here it is order ID, here it is customer ID. So okay, there is coming from here. All right, we can see that because I copied and pasted, I did not remember to rename the tables. We are using the singular version of it right here. Order and customer, not orders and customer. And it's possible you spotted it when I typed. Of course, there's no way you can say no, that's wrong. But eventually, now we are on the same page. So execute that. You can see that we have now everything looks normal. Okay, everything has been printed the way it is. If you still want to change this, you can go ahead and change it. Now, what if we want to spice things up and say these are use cases? I'm just trying to show you some other use cases. What if we have dates on both columns, right? So let's update this table. We'll just say date. We're just passing a string of values. Some dates 4,728, 4,000, 40,672, 40,000, 40,699, 40,711, 40,800, 40,000. Okay, I think it's just for 1, 2, 3, 4. Okay, that will do the split. By the way, if you're thinking these are not valid dates, they are. If you have a knowledge of Excel, you know that these are valid dates. Okay, they are valid dates. Okay, so right here I want to have dates as well. Just change the value to 3, 41, 41 as well, 43. And here this is showing an error. Okay, we have the comma to put here. That should be gone. Alright, it's gone. So now we have added dates, right? So we'll do shift enter, so it jumps into the next one. I think that's the same length. Okay, we have just 3 customers here, so we can remove let's remove this. Okay, so we want to run this, and now you can see automatically we're getting date X and date Y, right? We're getting date X and date Y. What if we wanted to print in a way that we know that, okay, this is from this particular table, this is from this particular table, right? We have an option to add a suffix. Okay, and that's what we want to do now, and then we'll close from here. I'll just copy this entire data set, or this entire code, and paste it here, paste, and then the last argument to add here is suffix. So suffix, suffixes in plural, and we'll pass in a tuple. Then for the first one, we want it to be order, so we'll say underscore order. And the second one will say underscore, let's say cost, We don't have to put in customer info. Run that. You can see now say date order, date customer. So we now see that we're getting we can now tell where the dates are coming from, which is much better. Okay, which is very nice. Now okay, so yes, we've seen different joins. We've come a long way, right? And if you need to go over all of this again, well, I'll say it's worth it. Alright, so finally let's just look at some hands-on. I think there's something that I left up here. Particular place where we did a break. Okay, break. Alright, right here, this is also meant to be we called it an hands-on, but I think I accidentally put it up there early. Cut this again, paste in here, cut this, paste in here, and Ctrl A and Ctrl X. Alright, so I can close this and delete this entire break. Okay, so we can see what will this be. Alright, so getting started with data frames. Alright, so let's just change this to getting started with data frames. Getting started with data frame. Alright, so that's nice. Now we can go all the way down. Okay, so I can just drop that up here. Okay, as a comment. So just create the data set right here. Okay. Paste. Pull. Just call this df or pd or retail. So system ID, I'm passing a list of random of sequence numbers. So 101 to 101. Okay, let's pass in the list ourselves. 101, 101, 102, 102, 103, 103. 103 as well. So I just have 3 103s. So that makes it 7. Don't say month. We can just split that up. January, February, January, Feb, Jan, Feb, and March. Okay, and finally you can see sales. Let's give some higher value than before. 3050, 3560, 2900. I'm passing empty value, none. 4200, 3980, it's 0. How many do we have? 1, 2, 3. 1, 2, 3. Okay, we want one more. So that can be, let's just say 4,100. Okay. So put a comma. Okay, I think we're good. So far, let's add one more data. Let's add transactions. Or one 20, 130, 110, 98, 150, as 160, 155, 158. Okay, so this is what we have, just a generic data set, and then we'll print the data frame out. Let's see what it looks like. We'll say retail. Alright. Ooh, okay, I omitted the splits on this, so do dot split, then I put a comma, I'll run that again. Okay, so we now have it correctly. Now you can see we passed in none, and of course it is not a number. That's still the way it will appear. So let's add a code up here. So let's check our data. Retail.info. So you can see store ID is integer. No, should have made that text. Dot split. Alright, run that again. Okay, an accidental. I forgot a comma. At what point did I forget a comma? Before 101. Okay, I forgot a full stop, not a comma, before split. Okay, good. So if we check this again now, this should be text. Alright, object, float, and integer. So the sales alone should be a text. So let's say describe. Let's say inspect. We're not claiming yet. So inspect. Alright. So just add few columns. So say retail.describe. And this is what we have. Sales and transaction. Now we can pass in a variable, an argument. I will say all. So you can see it's going to do for all. We want to get details about all the data. Of course, where is the number of just get? Because I cannot take average of non-numbers, non-numerical columns, and that's why most times by default it only picks numerical columns. Okay, so that's what we have. Any other thing to check? I think we're good. We have seen majority of what we need to see. So let's clean. So let's undo the missing value first. Based on what we did before, we can say retail, then sales, right? Sales, yeah. So that's where we have a missing value, and then we'll say df retail. I'm so used to DataFrame, so we'll say retail.sales. Then we'll say fill LA. In this case, we want to fill it with the average value of the sales. I keep typing retail.sales. and now say dot mean, right? So we did that earlier when we were looking at handling missing data. So this should not be strange anymore. If it's still strange, it's good you take this back and run it again. Okay, so we can just run that. That's the only thing we have. So if we print df retail again, we should not have any null value. You can see everything is now clean. So what else can we do? Now we've done handling missing values. So we can do feature engineering. Feature engineering, which is basically getting new columns from existing ones. So we can say, for example, retail, no retails dot average. What is our data done again? Okay, we can just say something. Let's say average ticket, and that can be. So I want to create a new column. Average ticket does not exist before. So retail sales single, then divided by retail, no relationship, retail transactions. Okay, so this will create a new column for us, and then we can print our data here. Retail.add. We don't want to see everything for now, we just want to see the first 5 rows. Okay, so you can see we now have this in there, first 5 records. Okay, so we can okay, I already have them listed here. Okay, I want to select some columns. So let's say I want to select some columns. We can just do df retail, my bad, retail, then store id, comma. So that should be a list of lists. So passing another list, square bracket and square bracket. This should be opening only. Okay, so I want to select just a few. I want to select the month, and I want to select the sales. So I can do .add again, but this time I just want the top 3. Okay, so you can see we can select certain columns and check what we have in there like that as we please. Okay, so let's filter greater than a certain amount. So we can say, okay, since we're using greater, so we can say I sales, then we'll say retail. As usual, we open the square brackets, then we pass in our condition inside the square bracket. So retail into brackets sales. So we'll say where sales is greater than, let's say 3,500. Then want to see I sales. Okay, so this is what we have. We have 1, we have 3, we have 4, we have 5, we have 6. Okay. Now is grouping and aggregation. Okay. So I want to group and aggregate. So you can say, for example, monthly summary, because we have different months. So you can say monthly summary is equals to, so come back here. So we can just open the parentheses and then declare everything we want to do. So say retail dot, no, just good way to organize our code, group by. So let's say, let's go back to our data. You can always reprint it down here. Retail. Okay, so the ID is duplicated, the month is also duplicated, right? So we can group by the sales and the month, or the store ID and the month. Store ID and the month. So we can then say the group by should be like this. Then dot aggregation, we want to aggregate. So for the aggregation, we can say total sales equals a tuple. Now the sales sum. Then we want to do transaction total, or total transaction. Total, how do we shorten transaction? Transactions. Okay, let's just do it that way. Total transactions, and in this case we want to pass in a tuple as well. Transactions. It's not coming up. Okay, I was waiting for that. And since it's numeric, we'll do a sum. And finally, average ticket. Then we say while jumping average underscore ticket. Mean, okay, mean, which is average. Okay, and finally we want to reset index, so we don't have that funny float that we used to get. Remember that? Okay, so this is nicely done. I'll just show monthly sales down here, a monthly summary. Alright, we're getting an error. Says tuple has no object, reset index. Okay, I passed that into the aggregate function. It's not supposed to be, so that is supposed to be outside on the same level as these guys, right? But outside the brackets. Okay, but to make this more clear, I'll bring this up. I think it's perfect like that. I'll just close the bracket at this point. Okay. Alright, so we open it here, we have all the list, and then I do a reset index at this point. Okay, what else are we missing again? So it says transaction does not exist as part of the column. Transactions, okay, that's in plural. I'll add S. I'll run it again. Fine. And now we get a total. We're grouping on two columns. So we can see what we have. Total number of transactions, the average tickets. And yes, I've just created a monthly sales summary. Just created a monthly sales summary for our data. Right. Alright, so far I hope you're enjoying the answer, right? Is there any other thing? Don't need this, so take it out and take it out. Okay, so we have completed the first one. If we go back up, I believe those are the objectives we have. Okay, not here. We have been able to do one or two things with these. You can feel free to expand on this. Now let's look at Anton 2. Now we have a scenario in this case, and the scenario says a hospital needs to merge patient demographic with lab results and generate a report for the data. Objective: but to clean messy string date columns, merge the data sets, create new features, that is feature engineering, and then export as CSV. We want a downloadable file, right? So that means the first thing we must do is let me take this out. We have to create a data set. Okay, that's why I left it up there. What was it again? We have to create a data set, and intentionally we have to put in messy maybe date string in there, right? So we want patient first, since we are merging the patient demographic with the lab results. So we want patient, then we say pd.dataframe, then we open this. Let's type patient ID. Since it's the patient table, we can just do ID instead. So we do ID, then pass in what's it called? Let's give them some random numbers. We don't want to really do much. So we can pass in a list, range, and then we should just pass in 1 to 5. Okay. So the next thing we want to have is name. And want to have it as, let's do intentionally passing John Doe. Should also have spaces. You know, we really want to mess things up. Well, we don't want to mess things up, but we want to simulate when things are messed up. So since we want to simulate the space and all of that, we don't want to do split in this case. So let's do it ourselves. And then we can say John Smith. Can say Mike Johnson, John okay, Mike Johnson, then we can say Mark okay, let's put in a good name, Bob Gaz. Alright. So this is the names of the patients, or these are the names of the patients. In this case, I want us to do something more fun. Let's say McLaurin. Then we use hyphen, so we can also take it out because we are not supposed to have hyphen in there. Okay, so put it in square brackets because we're not splitting. You can see how messy this is. Then the next thing is you want to put in, let's say DAB. Of course, details like this will not be public. Okay, so what can we split on? I think we can split on comma. So I'll do a split on this 1985 05 then 10. Then put a comma, so 1990. This time we're using slash, which is generally possible, right? 15, and we can say 1978. This time we're using hyphen again, 01 20, and finally we can use 1995 1201. Okay, so split on comma, so split on the comma, and then we say height, height in centimeter, right? So we know the unit, so we can just say 175 non 180 then 165. All right, so this is what we have for the patients. Now we have the patient settled. I think they just 4. Right, so what we do for lab, so say labs or lab results. Let's just keep it lab shorter. pd.dataframe. Okay, then open it up. Then say patient ID, patient underscore ID 1 2 3 4. So I can just copy this again. Patient ID, then we can say, let's say cholesterol level, cholesterol 180 190 210 170. Okay, HDL can put in 50 55 45 and what else 60, and let's put LDL as well, 110 120 140 is 95 now. Okay, let's take this out. So this is what we have now. We have both patient and lab data. So let's run our data code and print both of them and print them separately. Okay, and then print code patient first, patients, and then print the labs as well, labs. Okay, so run that. So you can see the spaces and the rest. And then we can do this, and then you can see the labs. By the way, HDL is high density lipoprotein and LDL is low density lipoprotein, and they're just they're both types of cholesterol in the blood, but they do opposite things. Okay, so the high density good cholesterol, low density bad cholesterol. No. Alright, now that we have our data sets, we want to clean, right? We want to clean them up because we really have them messy, especially the patient table. They are really messy. Okay, so how do we do that? We just call, for example, this column first, the name column. So we target the name column first. So we say patients square bracket, then put in the name, Then we'll say it will be equals to patient dot name again. Now remember to access this, because the type of patient name will be an object, so we have to use the string method to get it out, right? So we'll do .str, then we'll now pass in the method. So we want to strip it first, right? We'll remove the spaces. Remember we added extra spaces at the beginning. We'll remove the spaces. What else do we want to do? We want to give it a proper casing, so you can use the title case, first letter of every word. And for McLaurin, we want to remove the hyphen and pass in nothing. We want to take out the hyphen. So say .str again, then we'll say title, then finally replace, then we'll look for hyphen and replace it with nothing. Okay, so that's for the name. We have for the dates, and we have not probably worked with dates before, so we want to do for the dates. So we can say patients .dob. So let's look at what we have in the date. So we're seeing different formats, so we just want to convert it to an actual date or a proper date. So say patient again, then we'll pass in DOB. Now we have to say PD to date time, right? Remember when we do PD to numeric, so the same way we do PD to date time. So come here, okay, PD dot to, that's called date time. So we're passing this in, and we want to say if there is any error, remember we want to do what? Coerce it. Errors, then we'll say coerce. Alright, just like that. Then we'll close the bracket. So that will be for the date. For the height, let's see. Okay, we have a missing value, and I will fill the missing value with let's say the average height of others. Okay, fill it with the average height of the rest of the patients. So say patients dot height. Why is it not coming up? Yeah, we have heights there. Okay, we'll just type it in patient dot height underscore centimeter is equals to patient height in centimeter. Now do dot fill NA. I'll say patient height dot mean. Okay, so I want to fill it with the average of others. Is there another thing we want to do? Nothing else. That's basically the cleaning part that we want to do. Okay, so we'll run this and then we'll print patient at the bottom again. Okay, so if we look at this now, so everything is now looking proper. I feel okay, I omitted str right here because the hyphen is supposed to go, but I omitted str. So str again, dot replace. So let's do that. Okay, Good. So we have it this way, and our data is now clean. We can now proceed with what we want to do. And by the way, intuitively, even if you have not seen this before, we are seeing NAT, and earlier we have seen NAN, not a number. So what do you think this will be? Since this is the days column, so it will mean not a time. Okay, not a time. Why? Because it's not doesn't understand the slash. Okay, doesn't understand the slash. So one thing we could have done first is maybe replace, then so that we can get it correctly. But just so you see that we have not a time. That is why that is used there. So let's merge the two tables together. Let's say df, and then we're going to call it patients.merge. We can pass in lab, and then we'll say on. This should be on patient ID, patient underscore ID. I want it to be a left join, so we'll say how, and we'll say left. Okay, I think I should cut this up. To end, then print df right there. Okay, so we're getting a key error. Okay, if you remember, we used ID for patients, so say left left on ID, right on. Okay, so right on patient ID. So run that again, and now everything is now printed properly. So you can see we're able to merge the two tables together, so you can see the full details of the patients and their lab results in one go. Okay, so let's create more like a risk flag, right? We'll say high or normal or low, something like that. Okay, so just bring this into this place. Just take this out, and normal, etc. So for us to create that, we'll do our df, the merge table now, then cholesterol underscore risk. That means we're creating a new column, right? Feature engineering. Then we say mp dot where. So mp dot where. Remember, this is one of the ways we can maybe fill missing values or find something or replace something, right? To replace values. So we say df dot cholesterol. Now if the value is greater or equal to 200, that should go away. Okay, then it should be high, else it should be low. Okay, so we're saying look for this. If the value is greater than 200, it should be high, else it should be low. So let's print df again and see what that looks like. Okay, so just like that, we can see we have I. So this is the only high we have in there. So others are low. Normal, I think we should put it as normal, not low. Normal. So we have it as normal and I. Okay, let's continue. What else do we have? Okay, we want to create age group. Now for us to create the age group, we need to create an age column first, right? So for the age column, as I say today, pd.timestamp, then we can pass in date. I'm passing any date in there. Let's say 2026. Let's say 05 and 04. Just passing that date. And then say patients. Patients column age. Will now be today minus patients DOB. Patients DOB. Okay, what is off? Okay, I have two single quotes. Then we can do date time, right? We have DT, then we'll do days. So we can do a floor division by 365, and then print patients. Okay, let's see what this gives us. Alright, just like that, I've been able to get the column age for the patients. Okay, so that means we have to probably run this again. Okay, age is now included. Let's run this again as well. Alright, age is now included. So right here, we can now create the age group. Okay, so age group. I'll rename this to age. So here we now have age group. Then we can say df dot age group, which is a column that does not exist before, right? So you can see we have a method called pd dot cut. I will pass in div DataFrame age, pass in the bins, just the way we do for histogram. So we say 0, 29, 49, 120. Just jump like that. Then we say labels. Labels. Now for the labels, we need to pass it as a list. So passing a list. Then the first one can be less than 30, of course. The next person or the next group will be 30 to 49. Then we can say 50 plus, right? 50 plus. Okay, this should do. Then print our data frame again. That should not try an error. Alright. So of course this person doesn't have any age. So you can see the age range for individual person. So this is 41. This is okay. Let's do it in such a way that we cover this. No, it doesn't matter. Let's just leave it that way. Now finally, let's click on interactive sheets. No thanks. Now let us see that, but you can feel free to explore that on your own. Now finally, we need to export our data. So this new data can be exported as a result. Okay, how do we do that? We say df, then we use the method to CSV. You can see we have to CSV to clipboard to HTML to Excel. See all of them. So let's use to CSV this time, and then we'll call it let's say hospital claimed dot CSV. Now say index, say false, right? We don't want all of these these parts to be included. So it says index is false. You can then print maybe save to hospital, whatever it is. So I think we're good. Yes, we are. Okay, so this should download the saved file. Now we have to look for it under our file, and then under the files there, we should be able to find that particular file. Okay, so let's run it. Or there's another way by which we can download it to our what's it called, our machine directly. Okay, well, let's just run it first, then run it, then it's done. Let's check here. You can see like that. I can download it completely, and it should download. You can see it's downloaded like just like a CSV file. So we can open it up. I would say, do you want to convert? Don't convert. Alright, so this is what we have. So you can see exactly the data we worked with. You can see everything like that has been downloaded, and we can view it in Excel. So yes, we have now seen an hands-on exercise or hands-on exercises on how to use DataFrame for cleaning, for manipulation, for analysis, right? We've done pivot table, group by, summary, and all, right? So just a little exercise for you to strengthen your hand more on what you've learned. We'll take the exercise we just finished a little bit further for you. Okay, so back to our Google Colab. I'll just close this. Let's look at what we have for you. So hands-on for you. Now you can calculate the BMI, right, using weights. So just create some dummy weights, some fake weights. Okay, so create weights, add it to the data set, then create the ratio, LDL HDL ratio, and flag anything as 3.5, greater than 3.5 as risk. Then split the name into first name and last name. Okay, if you want more, you want to go further, you can create a reusable function that can clean the name, right? You can take a column, clean all the names, standardize casing, spaces, removing all of those things. You can do much more with that, and it is a good thing that you give it a good shot. Okay, so when you're done, copy the link to your notebook. Just click on this button here that says share, copy the link to your notebook and share in the. So when you're done, copy the link to your notebook. If you click on share notebook, it's going to pop up. Then you set it to anyone with the link. You copy that link and paste in the Telegram channel below. Link to join is in the description below. And here for this and more on Python, I'll see you in the next video. Alright guys, welcome to another video, and in this video we will be looking at how to read or how to work with different files. So let me just make this working with multiple files, different types. Okay, so this is what we want to see. I want to see how to work with multiple files, different files. So far we have been creating our own data frame, our own data sets. What if we have existing file? Not even what if, in the reality of it, we will have existing files, right? So it could be maybe we want to do web scraping, right? We go online, we want to grab a particular data, or we have an actual file we want to work with, or we want to connect to an SQL file, okay? We want to connect to an SQL database, but now in this particular one, let's see how to connect with multiple files, okay? Let's jump into it right away. So we'll be using a data set that has varieties, right? So let me just show you the data set first. Now, it is possible that you might remember this data set. That's if you're not new to this channel, you probably know this data set. We used it in SQL or in Power BI majorly. Yeah, this is the data set we use in Power BI. Similar to it is what we used in SQL before. Similar to it, that means a different version of it. But this particular version is so nice because it has different files, and we probably want to do some merging, some combining, some joining in this file, right? So the link to this file will be in the description below, so you can grab this file. It will come as a zip. All you have to do is what? You right click it. Okay, you select it first, then you right click. Once you download it, so it's going to wait, just wait for that to load. And we want to click on show more options, okay? Or you can click on wherever directly here and do extract, but it's better to go to show more options, and then you should get the option for extract all. So once you extract all, it's going to show you a folder. Then when you open it, you'll find these 3 folders in there, and then you can open individual folders to find individual files, okay? So how do we bring this in to our data or into our Colab environment? We have multiple ways, or a few ways of doing it. We can load it to our Google Drive first, so that we can always reuse it. But if we don't want to load it to our Google Drive, let's say it's just a temporary thing to do, so we just want to use it for that particular session, and maybe when we're done with it, we'll save it as a file again, which we have seen earlier, to CSV. We just have to save the variable name, then dot to CSV. I think it's still right here. If we scroll all the way down, right, okay, after this hospital data, so yeah, right here we just have to say to CSV. So if we want it to Excel, to whatever it is we want it, Python have all of those options for us. Okay, so let's just see how to quickly load in this data, combine them, and work with them. Just collapse that. Alright, so collapse the answer, and let's see that quickly. So we can make this data available temporarily within our session, right? So just click on this folder icon on the left, right? And then you see all of the options. You see the option to mount to Google Drive. If you want to upload it to Google Drive, then so that you can reuse the file again and again, just mount your drive. Then it's possible that Colab will just prompt you to connect your Google Drive to your Colab, right? Which is simple, just to allow or accept whatever you're seeing on your screen. You read it, of course, and then you see that Colab is asking you to connect to your Google Drive, asking you for access. Or it can show you a code in here that's from Colab, import this, and then connect your drive to it. Whichever way you need to give access to connect a Colab into it. But for the sake of this video, we're just using that as a temporary session, so that when this session gets destroyed, if we are not going to ever use that file again, it doesn't just occupy the space in our drive. Okay, so let's go back to the file. So this is what we have, and right here we want to pull all these files, right? So let's start with the customer. I'll open the file, then highlight everything, and then I'm just going to dump it like this. So it's just going to be available only for this session, only for this session. Again, I'll dump the rest, go back here, open the products. Don't forget that the products is an XML file, I'll dump it here as well. Alright, go back there, and then I want to get the sales file. Well, since the sales is also a CSV file, just like this, I'll just disregard it. I only want to show you how to combine these files, work with them, how to read them. So we're not really doing anything with the data in this particular video, so I will not be showing you how to do this. However, you can drag the two as well, dump it here, and then you connect the two to have a full data set. Okay, because you'll be having exercises to do with it just right after. So now we have all of these files. What I want to do is to copy the file path. I'll say copy path and just paste it in here. So obviously, if this is the file path for the first one, that means I'll just have to change to east, south, west, central, like that. And for the product data, it should be the same, but let me just copy that, copy paths, and then I'll paste in here. Okay, so let's import NumPy. Pandas as PD rather. So we're using Pandas to read the data. Alright, so execute that, jump to the next cell. So Pandas is now available for us. I think I can close this now. So let's write some variables where we're saving all of this. So we can save east or central, then east, then south, then west. Okay, so we say pd dot read underscore csv, because this one is a csv file, and all we have to do is, though as much as we have quite a number of things we can pass in, okay, we we can pass in just the file path. You can see first thing it says file path. If we have a separator to pass in, we can also pass it in. You see, delimiter, header, does it have header? No, all things like that, we can always do that. So I'll copy this file path, Ctrl C, now put it inside the bracket, Ctrl V. So I'll copy this and paste it again, Ctrl C, and I'll change this to east, paste this here. Alright, let's make this bigger. Now scroll up a bit. Okay, so this will be what? West or south. This will be south, and finally we want west. Alright, so for the product, so just say copy this, but this time we're reading an XML file, so we'll do read underscore XML. You can see we have Excel option right there as well. So copy this, let's cut it this time and take away all of this. Okay, quote. So here we can read all our files and do central dot add, just to inspect all the files. East, south, west, and product. Let's run this first. Okay, no error. Now comment this out, just run everything. See, we're only getting the last one as usual. So let's comment everything out. /. Okay, and you can see what we have about customer ID, customer segment, customer ID, customer name, segment, age, and all the rest of the data. So you can uncheck everything one after the other and run it to have it there. So we can check the data type. Let's see how Python, let's use West this time, .info. If you look at West.info, okay, so age is correctly picked as number, postal code as number. Okay, I think we're good. So it's good to check all of them like that. And we have seen that our product as well. Let me take out the product from here just to inspect it. Okay, and see our product also is successfully loaded. All right, now the idea of this is that this particular data set, for example the central, east, west, is assumed that each region collected their data separately, but we have the same columns in them. We have the same columns for everything, so that means we can combine all the data. Now in this case, we don't want to join. We're not necessarily joining because it's still the same customer table one. It's not like we're joining a customer south to customer west, but we want to combine them. In Power BI, we did that as append, where we just stack the data on top of each other. For example, let's say we have 30 customers in the central region. So for east, we want to start at 31. Let's say we have 20 for east, so by 51 we want to start for south. So that's the idea of what we want to do, right? So how do we do that? So we can just create a new variable called customers, and then we can say pd dot concat. So with this option, we can combine all the 4 files once and for all, and it is very, very easy to do. Very, very easy to do. So we'll just pass in a list of the variables. So we have central, we have east, we have south, and we have west. Okay, so this is what we have, and we have passed in what we want to concat. We have other options we can add. Okay, but let's just see what this looks like eventually. Let's take this out. So let's do customers.head. Okay. Shift enter. Let's run this. And just like that, we have been able to concatenate the data. So what if we want to actually find out? So let's see where customers. So we just want to filter the data so we can be sure we have all the rest of the data there. So say where customer dot region equal central. Okay, this is central, so I want to say east equal east. So I want to grab the head for the east region. So let's see. Okay, good. We have east in there. You can see we have east there. What if we want to grab for west or south first? So just to check that we successfully grabbed all the data. Okay, south, you can see it here, south. finally, what if we want to grab for west? So you can see we're able to grab all the data. So that means it combined all the data for us. So let's do a grouping and aggregation just to count the number of customers. So we can say customers dot group by. So let's say we're grouping by the region, and then we want to count. So we want to count the customer ID. How is it written? Customer ID, and that will be a count. Right. So let's check. You can see, and yes, we now have the total number of customers right there. You can see all of this should give us the total number we have in the original data. Let's check customers.shape. Customers.shape. So this will tell us the number of rows and columns. You can see 793 plus 793 by 9. So we have 793 records, 9 columns. So if you add all of this up, it should give us the same thing. So that means we have been able to combine, customer record everything. So we have, if you combine this, that should give us 793. And yes, we have been able to combine all of these files. And yes, we have also been able to read our product data. So with this, we can start doing, we can create a join. That's if we had brought in sales, we can start creating joins and start doing manipulation on a larger scale. And when we're done, we can always export our result out. Okay, we can always export our result out. So let's say we want to ignore index. For this, let's run this. Ignore index. Is that not coming up? We'll pass it in anyway. The index. Check concat. Concat should have object arguments. So it has join. The default is outer join. Okay. If you want to do an inner join, you can do that. So ignore index here. So see it's right there. So ignore index. So say ignore index equals to true. So run that again. Run this again. Alright. So you can see now that it's now giving us the correct version. We're not seeing the should I say fake version of what we were seeing earlier. So where's the customer again? I think let's just run actual customer as well. Customers.add. Okay, so everything is nice and I think we're good to go. So now you know how to load in data. If it's an Excel file, you just have to read it that way. Very easy. If you have some sheet names, you can specify them when you're loading it. Say for example, you just have to read the argument, and that's what makes you stand out. That's what makes you show that you are actively learning, not just because if the only thing you can do is what you see on the screen, what you see me do, then you have to put in more effort. Okay, you should be able to do things on your own, and that's why I show you as much hints and tips as possible. So I'm not holding anything from you. I show that okay, you can go all the way like this to do this. So let's say for example we want to say Excel DataFrame or sample data. We'll do pd.read_Excel. I don't have an Excel file I want to read right now, so just want to show you the arguments we get. Okay, so you can see for read Excel, the file part is the first thing. You can just come here instead. If all of these are, I think there's a place where it explains it one by one. So you can see. So after the file part, sheet name. If you want to pick a particular sheet only, you pass in the sheet name, header, what else? Index column. You see that you pass in the sheet name or you pass in the index column. The index column in this case will be which sheet. You pass it by index. See, you have other options there. You can just take a minute, go through it, test things out, run them, and then get a good hang of it. Okay. So with this, you can now load files, work with files, do as much as you need to do. Now, do not forget that this session gets destroyed once these variables disappear once the session gets destroyed. So I'd like you to load in. Once you download the file, also bring in your sales data, combine it, and start answering some questions. Start doing some analysis. Let's say region-wise analysis. You want to do total revenue by region, total sales by region, number of customer by region, different things like that. You can, and you remember that this data set is actually interesting. I think I'll leave a link to the description below in the Telegram channel where we created some new columns, right? Using this data in Power BI, you can replicate all of those things in Excel, in Python here, and also leave a link to the description to where we created a dashboard for it, so that you can just create, you can just answer the questions manually here. So for example, if we do segments by profit, you can also do it segment by profit, not with the chart yet, but you'll be able to write a code to show it. Alright, with that and more, I'll see you in the next video. Until then, keep practicing, and keep practicing.